Chapter 12. The Theory Illustrated, by Adducing Examples from the Different Quarters of the Globe. The system which we investigate is universal on this earth, it hangs upon the growth of plants, and life of animals. It cannot have one rule in Europe, and another in India, although there may be animals and plants, the constitutions of which are properly adapted to certain climates, and not to others. The operation of a central fire, in making solid land on which the breathing animals are placed, and the influences of the atmosphere, in making of that solid land loose soil for the service of the vegetable system, are parts in the economy of this world which must be everywhere distinguishable. But this the reader is not to take upon my bare assertion, and I would wish to carry him, by the observations of other men, to all the quarters of the globe. Mr. Marsden, without pretending to be a natural historian, gives us a very good picture of the water-worn surface of Sumatra. History of Sumatra, page 20. Along the western coast of the island, the low country, or space of land which extends from the sea shore to the foot of the mountains, is intersected and rendered uneven to a surprising degree, by swamps, whose irregular and winding course may in some places be traced in a continual chain for many miles till they discharge themselves either into the sea, or some neighboring lake, or the fens that are so commonly found near the banks of the larger rivers, and receive their overflowings in the rainy monsoons. The spots of land, which these swamps encompass, become so many islands and peninsulas, sometimes flat at the top, and often mere ridges, having in some places, a gentle declivity, and in others descending almost perpendicularly to the depth of 100 feet. In few parts of the country of Bencoolen or of the northern districts adjacent to it, could a tolerable level space of 400 yards be marked out, about Sugilamo in particular. There is not a plain to be met with of the fourth part of that extent. I have often from an elevated situation, where a wider range was subjected to the eye, surveyed with admiration the uncommon face which nature assumes, and made inquiries and attended to conjectures on the causes of those inequalities. Some chose to attribute them to the successive concussions of earthquakes, through a course of centuries. But they do not seem to be the effect of such a cause. There are no abrupt fissures. The hollows and swellings are for the most part smooth and regularly sloping, so as to exhibit not unfrequently, the appearance of an amphitheatre, and they are clothed with verdure from the summit to the edge of the swamp. From this latter circumstance, it is also evident that they are not, as others suppose, occasioned by the falls of heavy rains that deluge the country for one half of the year. The most summary way for accounting for this extraordinary unevenness of the surface were to conclude, that in the original construction of our globe, Sumatra was thus formed by the same hand which spread out the sandy plains of Arabia, and raised up the Alps and Andes beyond the regions of the clouds. Our author then, after reprobating this idea, endeavors to explain the appearance here examined by the constant though imperceptible operation of springs. The present purpose is not so much concerning the explanation of those appearances, as to inquire if these be the general appearances of things over all the surface of the earth. The general appearance here is that of land washed away upon the surface by water, which has everywhere left the marks of its operation in the shape of the ground. As for any particulars in the shape of this water-worn surface, this can only be explained in knowing the nature of the soil and solid parts, and the circumstances of the operation in which they have been wasted. If the shape of the land here described by Mr. Marsden has been produced by means of water, it must be by water moving from a higher to a lower place. And, in that respect, it is the same operation which everywhere prevails, in producing similar effects, although it is not everywhere that this effect comes to be the object of our notice. It is therefore so necessary to illustrate, in giving a diversity of cases. But it is not every case that can be understood as belonging to this rule. For, though the shape of every part has been modified by the operation of this cause, it is not everywhere that this relation of cause and effect is immediately perceived. There must be a certain regularity in the parts to be described, and a certain conformity which those in which we have no doubt, or in which we certainly acknowledge the efficacy of the cause. In America, this system of swamps and savannas are to be found upon a large scale, but for this very reason, they are not so remarkable to men. Man only sees a system of things, so far as that system is more immediately within the reach of his perception. For, without having prepared media, by which he may compare things that are distant either in their nature or their place, how could he judge those things to be connected in a system? It is in this manner that, seeing only the small part of an extended system of things, he sees no system in it, and, consequently he cannot give any scientifical description of the subject. There is another case in which men of science, or systematizing men, are apt to fall into delusion. It is not from any deficiency of seeing effects, and knowing general causes. It is from the misapplication of known causes to effects which are perceived. We have a remarkable example of this in the view which M. de Bugger has taken of a singular appearance which he met with, perhaps more interesting to the present theory than almost any other of which we know. Voyage au Perot, page 89. Un particularite que a attire sauvant mon attention dans tout ces contras, c'est que tous les montagnes opers desquels j'ai passois, et que sont au pied au dehors de la grande cordillère. Me paroissoin avoir eu un origine tout different de celles que j'avois vues auparavant. Les lits de différentes terres et le plus sauvant de rochers dont elles étoyant formes, n'étoyant pas inclines de divers côtés, comme dans les autres, ils étoyant parfaitement horizontaux. Edj les voies quelquefois se répandre fort loin dans les différentes montagnes. La plupart de celles-ci ont du ou 300 toises de hauteur, et elles sont presque toutes inaccessibles. Elles sont souvent escarpées comme de murales, c'est ce que permet de mieux voir leurs lits horizontaux dont elles présentent l'extrémité. Le spectacle qu'elles fournissent n'est pas riant, mais il est rare et singulier. Lorsque le hasard a voulu que quelqu'un fût rond, et qu'elle s'y trouvat absolument détaché de autres, chacun de ces lits est devenu comme un cylindre très plat, ou comme un cône tronc que n'a que très peu de hauteur. Ces différents lits places les uns au-dessus de autres, et distingués par leurs couleurs et par les divers talus de leur contour, ont souvent donné toute la forme d'ouvrage artificiel et fait avec la plus grande régularité. Il est un de ces montagnes à environ un le de Honda sur le bord du Guali et sur le chemin de Mariquita, que est exposé à la vue de tous les voyageurs. Mais je sens que SIJN donnois ICI une représentation Illinois faudrait que je compte sur le crédit que doit naturellement avoir le rapport de quelqu'un que n'a aucun intérêt d'altérer la vérité. Et que a en tout va le plus grand éloignement pour le mensonge. En voit dans ces pays la les montagnes y prendre continuellement l'aspect d'anciens et édifices, de chapelles, de domes, de châteaux, quelquefois ces sont de fortifications formes de longues courtins munis de boulevards. Il est difficile lorsqu'on observe tous ces objets et la manière dont leurs couches se répondent, de doubter que le terrain n'est soit base tout autre. Il pourrait que ces montagnes dont la base est plus solidement appuyée, sont restes comme de species de témoins au lieu de monuments que indiquent la hauteur qu'avoit anciennement le sol. There are but two ways in which those appearances may be explained. One of these is that which M. Bugger has adopted. The other, again, belongs to the present theory, which represents the action of running water upon the surface of the earth as instrumental in producing its particular forms, and thus forming many natural appearances upon the surface of the earth. The first of these, viz. that a mass of solid land, in such a shape as that here described, should remain while all around it sinks, is an opinion which, however possible it may be, is not supported, I believe, by any example in nature. The last again, viz. that the parts around those insulated masses, and those that had intervened between the corresponding mountains, have been carried away by the natural operation of the rivers, is not only the most easy to conceive, but is also, so far as those operations are concerned, conform to every appearance upon the surface of the globe. It is not necessary to go to South America, and the rivers of the Cordilleras, for examples to illustrate that which every one may see performed almost at his own door. But it is there that an example has occurred, which, though it has imposed upon an eminent philosopher, cannot properly be employed in support of any other theory but the present. Our author proceeds. Je connais les environs de l'Orno que par relation, mais j'escais chuen plusieurs endroits les montagnes y sont également formes de couches horizontales. Et quels ont souvent en haut de plateformes que sont exactement de niveau. On any trouvé à ce que je crois rien de semblable au pero malgré la variété presque infinie que y est répandu. Toutes les couches y vont en s'inclinant autour de chaque sommet, en se conformant à la pente de collines. It would appear that it is a rare thing to find a great extent of indurated strata in a horizontal position. Now, this circumstance is necessary in affording the appearances here considered. Those particular appearances, therefore, are only to be found more partially in other places, where the strata are inclined. If here, therefore, where the strata are horizontal, and where the spaces between the summits of those mountains had evidently been as solid as the masses which remain, we find mountains formed by the waste of land. And a system of rivers forming valleys amidst these mountains, have we not reason to conclude, that in other mountainous regions, where the regular position of the strata has been broken and confounded, and where the same system of river and valley universally is found, the form of the surface has been produced upon no other principle than that of the natural waste of the solid mass, and the washing down of the heights for the formation of the fertile plains? Nothing can tend more to illustrate the theory than a proper comparison of the old world with that which is called the new. It is not that we are to expect to see the operation of a longer time, upon the one of those continents, compared with the other. We equally lose all measure of time, in tracing the operations of nature on either continent. But in those operations there is rule to be observed, and the question is, if the same order of things may be perceived in all the quarters of the globe? This is a question which the learned, even, in their closet, may be able to decide. They have but to look at the maps to be convinced that everywhere the process of nature, in forming habitable countries, is uniform, and that the system of what is called the watering those countries with rivers, is universally the same. A system which is now considered as giving us a view of the operations of water wearing down the land which it has fertilized, and shaping the surface of the earth so as to make it on the whole most useful. There cannot be a doubt of the effects of those natural operations which belong to the surface of the earth, and which affect more powerfully the surfaces of the mountains. The only question is with regard to the general amount of those operations, and to the particular occasions which may have concurred in producing those effects. These questions can only be resolved in making particular observations. A general theory may thus be formed, of those operations by which the surface of the earth above the level of the sea has been changed, and will continue to be so as long as it remains a surface exposed to the influence of those agents which must be acknowledged in this place. Naturalists, who have examined the various parts of the earth, almost all agree in this, that great effects have been produced by water moving upon the surface of the earth. But they often differ with respect to the cause of that motion, and also as to the time or manner in which the effect is brought about. Some suppose great catastrophes to have occasioned sudden changes upon the surface, in having removed immense quantities of the solid body, and in having deposited parts of the removed mass at great distances from their original beds. Others again, in acknowledging the natural operations which we see upon the surface of the earth, have only supposed certain occasions in which the consequence of those natural operations have been extremely violent, in order to explain to themselves appearances which they know not how to reconcile with the ordinary effects of those destructive causes. The theory of the earth which I would here illustrate is founded upon the greatest catastrophes which can happen to the earth, that is, in being raised from the bottom of the sea, and elevated to the summits of a continent, and in being again sunk from its elevated station to be buried under that mass of water from whence it had originally come. But the changes which we are now investigating have no farther relation to those great catastrophes, except in so far as these great operations of the globe have put the solid land in such a situation as to be affected by the atmospheric influences and operations of the surface. The water from the atmosphere, collected upon the surface of the earth, forms channels to itself in running towards the sea or lower ground. And it is these channels, increasing in their size as they are diminished in number by the uniting of their waters, that give so clear a prospect of the operations of time past, and prove the theory of the land being in a continual state of decay, and necessarily wasted for the purpose of this world. Every description, therefore, of a river and its valleys, from its sources in the mountains to its mouth where it delivers those waters to the sea, is interesting to the present theory, which is the generalization of those facts by which the end or intention of nature is to be observed. M. Reboul, in a memoir read to the Academy of Sciences at Paris in 1788, has given a very distinct view of the Vallée du Gave Bernois dans les Pyrénées. There are many things interesting in this memoir, and I shall now endeavour to avail myself of it. Le torrent que porte le nom de Gave de Pau parcourt depuis sa source près de limites de l'Espagne, jusqu'à la petite ville de Lourdes, en vallée que se dirige du sud au nord sur une longueur d'environ 10 lieues. Cette espace, que forme son lit dans l'intérieur de Pyrénées, ressemble moins à une vallée dans la majeure partie de son étendue, tué un intel étroit et profond, dont les flancs sont souvent coupes à pic d'une hauteur effrayante, et dont le fond est toujours couvert d'une eau écumeuse. Cette longue coupure se termine, ainsi que plusieurs de ses branches, aux sommets les plus élevés de Pyrénées, et elle recueille les eaux que distillent sans cesse de leur neige dessus. Sa division géographique est en deux vallées, dont l'un plus voisin de la plaine est appelé l'Avedon, et dont l'autre en fait que partie de la country que porte le nom de Bareges. From the summit of that ridge of mountains which run from the Atlantic to the Mediterranean, the valleys of the principal rivers run from the south northward towards the plain of France. From this again they turn westward in order to find their way to the sea. The mountains, which then separate these rivers from the plain, are composed of schistous and great collections of water-worn gravel which had come from the mountains of the Pyrenees. Upon this occasion Mr. Reboul observes, Les ruines amoncelées et la grande quantité de cailloux roules que forment ces digues naturelles, invitent sans de la penser que ces sont les torrents eux-mêmes que ont comble leur lit et obstrue leur passage. Mais on n'y peut concevoir que cet fait et pu avoir lu que dans de temps très reculs, et avant l'entière excavation de vallées. Peut-être pourrait-il naturel d'imaginer que les masses out été produites par le conflit de eaux que se précipitent de montagnes et de flottes de la mer, lorsqu'elles recouvrent encore les plaines, etc. Je fatiguerai point le lecteur du dénombrement inutile de tous les bancs pierreux de ces substances que se succèdent le long de la vallée, et prenant seulement le résultat de mes observations. Je me bornerai à dire que depuis Lourdes jusqu'à Luz, les parois de la gorge sont alternativement composées de matters argillaceus et de calcaires, quelquefois sous la forme de couches diversement inclines, mais plus souvent fissiles. Montrant de fuelets de différentes grandeurs et d'un tissu plus ou moins compact. Ces schists hétérogènes sont presque toujours entassés et superposés dans la même montagne, mais en plusieurs endroits un seul genre prédomine, etc. L'espèce d'uniformité que semble exister dans la composition de ces masses, n'est trouvée nullement dans leurs dispositions. On chercherait en vain dans leurs couches en direction et en inclinaison générale et constante, on pourrait tout au plus hasarder à ces sujets de légères conjectures. Mais si l'ordre primitif de ces montagnes est dérobe à l'œil de l'observateur, on trouve à chaque pas de indices certains, de marques évidentes de la manière dont il a été alteré au lieu de trot. Je reconnais d'abord que les mêmes cailloux, les mêmes débris de marbre et d'ardoise que couvrent le fond de la vallée, et que le gaven train et remplacé sans cesse, se trouvent aussi à plusieurs toises au-dessus de son niveau. Je vois quelquefois les sediments fluviatiles recouverts et ensevelis sous de grandes masses de pierre feuilletée adhérentes à la montagne. Levant en sous les yeux, j'ai observé que de l'un au de l'autre côté du torrent, les flancs de montagnes étoient souvent couverts et complexes de semblables masses de schiste. Dont les couches et les fuelets offroyant toujours de directions contraires à celles de schistes de même nature, auxquels ils toyant audaces. Les eaux du torrent, que ont sans de renvers ces couches sur els mêmes, ont deposed de marques de leur passage. Els ont abandon, engage sous ces debris mêmes, à de grandes hauteurs, de blocs énormes de granit que le voyageur surprise voit pendre sur sa tête. De pareils blocs arrondis et uses couvrant le fond de la vallée, et opposant quelquefois au torrent en digue que le fait jailer et retomber en écume. Enfin j'ai suivi les traces de ces courant aux différentes hauteurs de parois du canal OIL col aujourd'hui à plusieurs centaines de toises de profondeur. Il a dû les parcours tout successivement en creusant et rétrécissant sans lit et augmentant sa vitesse. Les crêtes de sommites que forment les bords les plus élevés de la gorge, sont escarpés dans la direction du courant. J'ai aperçu quelquefois de portions de montagnes séparées de la crête, au lieu du sommet principal, et dont les eaux semblant en avoir fait de species d'îles, en creusant autour d'elles une fosse profonde. Elle en voit fort bien les angles salants de elle correspondre aux angles rentrants de la montagne, etc. Dans la partie de la vallée où est observant ces phénomènes, on marque toujours entre deux montagnes resserrées, dont les nuages dérivant souvent les cimes. Mais partout où les eaux de quelque torrent considerable viennent se réunir à celles du Gave, Illinois est forme un bassin d'une étendue moyenne. Que n'y fait d'abord vraisemblablement une grande mer d'eau semblable à ces lacs que existent encore dans le sein de Pyrénées et de Alpes. Ainsi en voit, à un lieu avant argiles, les montagnes s'écartèrent, se replièrent en un vaste circuit, et en tour, comme d'une muraille stérile et ruineuse, de prairies arrosées par mille canaux et par le brouillard de cascades. De coteaux, où elle en voit s'élèver, parmi les verdures et les bois, de villages ornés de marbre, de châteaux majestueux et les délicieuses habitations de quelques moines fortunes. Le penchant que borde ces vallons du côté de l'est n'est creusé que par quelques ravins très inclines, dont les eaux se précipitent en écume et disparaissent, avant d'arriver au bas de la montagne. Sous l'ombre de bois et d'une foulée d'habitations rustiques, mais le penchant de l'ouest, plus profondément excave par les torrents, présentent les issues de trois autres vallées. Dont les deux principales vont prendre leurs origines aux limites de l'Espagne. L'autre, plus voisine de la plaine, est à peu près dirigée de l'est à l'ouest. Elles s'appellent extrême de sales, et joint SCSOs à celles du Gave un peu au-delà de l'extrémité intérieure de ces grand bassin chuel à concouru à former. C'est au centre du bassin, opers du village d'Argiles, que le Gave d'Azan arrive avec fracas, et c'est à son extrémité supérieure que le Gave de Cotters sy précipite en sortant d'une gorge dont l'aspect frappé d'étonnement et d'horreur. Le cours de ces du Gaves est opers de leur embouchure oblique à celui du Gave principal, mais ilssi repliant ensuite vers le centre de la chaîne et deviennent presque parallèles. Opers de luz se découvre un autre bassin se joignant les eaux du Gave à celles du torrent de la Lise, que na creuse un ravin, et à celles du Buston que descend d'un vallon très évasé dans la direction de l'est à l'ouest. Se trouvant les eaux minérales de Bareges. Ce nouveau bassin en offre que le spectacles d'une vaste prairie bordée de montagnes prodigieuses. J'ai en entreprendrai point de rein adjuter ici touchant ces diverses branches de la vallée du Gave bernois. Chacune d'elles exigeroit une description détaillée, soit à cause de son étendue, soit à cause de la variété de ces phénomènes. De luz à gouverner le Gave se trouvé de nouveau resserre dans un gorge étroite où les montagnes paroissent encore s'élever et les abîmes s'enfoncer. SESOs ni coulant plus en cascades brillantes, et quelquefois le voyageur, que les voit écumer sous SES pites du haut du centre sur la montagne, entend à peine un murmure lointain. On y remarque de nouveau les phénomènes, décrits ci-devant, de pierres feuilletés renversés de leur première direction, de bancs entiers courbes et brises dans leur chute, de débris granitiques arrondis par les eaux. Déposes à de très grandes hauteurs dans le fond de ravins où le courant n'existe plus, etc. A guédre le gave recueillit les eaux de his, le devenu célèbre et enrichi par la dévotion espagnole. A peine est-on passé le torrent, que le granit commence à paroître. Le gave roule ses eaux sur cette base il entame difficilement, aussi son lit est plus large et la gorge moins profonde, le granit se monter en terre sous de grandes montagnes calcaires. Du côté de l'ouest il est presque toujours recouvert de ces masses qu'on distingue de loin à leur teinte grise et blanchâtre mêlée de sillons d'un rouge pouffant. À l'est les montagnes calcaires laissant le granit à découvert, et lui demeurant comme assises. Celles que leur succèdent offrant de marques, effrayantes de décrépitude. Leurs crêtes sont démantelées, et leurs flancs sont lézards et harasses de rochers suspendus. Le fond de la vallée semble ensevelie sous les débris de cette montagne à demi écrasées. On trouve, parmi les ruines, de blocs de plusieurs milliers de petits cubes. Le gave les couvre quelquefois de SESOs, se précipite dans les intervalles QILS les cententrieux, et renate comme sous un voûte affaissé. Plusieurs de ces lambeaux affectent sur leurs plans la forme de parallélogrammes et de rectangles. Mais ce que l'on voit encore attaches au corps de la montagne, sont pour la plupart pyramidoques, et sa crête est formée d'une suite de ces pyramides granitiques. Toutefois on ne peut pas se refuser à voir que le granit est ici dispose en couches très distincts que paroissent surmontés dans quelques points de sommets, de bancs calcaires. La direction de ces couches granitiques n'est pas constante dans toute la masse, elles semblent s'incliner vers le sud-ouest du côté de Gavarnie, et vers le nord-est du côté de Guédre. Quoique leur substance soit mêlée de plusieurs roches hétérogènes, elle est généralement composée de quartz, de feldspath, et de mica. Mais ces deux substances white sont dans un état frappant de décomposition, et semblent quelquefois réduites en chaux de fer. Au-delà de leurs débris, dont l'amas est désigné par le montagnard sous le nom de pyrédite sous celui de Cadios par les gens du monde, le granit est de nouveau surmont de substances calcaires. Il sort de base aux pics coniques de comely et de pymene. Cette base forme elle-même un vaste montagne qu'on appelle allens. Ces roches, d'un granit ferruginique et sombre, sont entourées d'une couronne blanchâtre et calcaire, au végétant quelques sapins épars, Gavarnie est à ses pites. C'est à une légère distance de ces villages, que se termine la vallée du Gave Bernois, où plutôt elle prend naissance avec le torrent que elle est formée. On aperçoit de loin les vastes sommets et les champs élevés de neige et de glace d'eau se précipitant. On reconnaît en ce QILS ni formant une montagne ou plutôt une masse énorme par sa hauteur et son volume, composé d'une même matière, et que, placé sur un base vers lequel on ne cesse de monter pendant l'espace de 10 lieues. S'élève tout à coup de sept à huit cents toises, et domine au loin toutes les montagnes que l'entourent. Les différents sommets dont elle est couronnée se présentent sous mille formes bizarres. Ce sont de pyramides irrégulières et de vastes cylindres, au lieu de cônes troncs près de leur base, que ressemblent à ces de tours écrasées. Les crêtes, que sont formes du prolongement de ces sommets, sont autant de murailles inaccessibles bords d'un long tas de ruines au lieu d'une large fosse de neige glacée, et quelquefois interrompues par de breaks profonds. On ne peut apercevoir tous ces objets du fond de la vallée, et il faut s'élever sur quelque hauteur voisine, tel que le sommet de Bergens, au lieu celui de Pymene, pour embrasser toutes les parties de ces vastes tableaux. En remontant vers les sources du Gave, qu'en occupe le centre, on pénètre par une coupure plus profonde dans une prairie de formes ovales régulières bordées à l'est et à l'ouest par de hauteurs plantées de sapins et de heaters. Idio sud par un almas de rochers écroles, e par les sommets que je viens de décrire. Le gave y serpent sur un lit de sable et de caillou, et recoit les eaux que descendent, en écument, de hauteurs voisines. Ilse fray un chemin vers cette prairie parmi les débris antices que le bornent au sud, et que la séparent d'une autre bassin non moins vaste, o le torrent commence son cours, et o la montagne s'élève tout hauteur en un rempart inaccessible. On peut prendre une idée légère et imparfaite de cette majestueuse enceinte, and se la figurant comme un amphithéâtre moins remarquable par la vaste étendue de son arène que par la hauteur prodigieuse de ses murs. Par tout boards de parties saillantes, d'écuncrures profondes, et harrisses de rochers dont la ruine est prochaine, se sont entièrement écroles du côté du nord. Elle est couronnée vers le sud par du sommet cylindriques recouverts d'une croûte épaisse de neige durcie, et que leur fourmille fait nommer tour de marbre. Au-dessus se succèdent, en fourmi de gradins, de vastes plates-bandes d'une neige que any disparoit jamais, et que any cesse point de s'y fondre insensiblement. Les eaux produites par cette stellation continuelle se divisent en sept ou huit petits torrents que naissent sous ces lits de glace, et roulant sur le penchant rapide de la montagne ou jaillissent en cascades, quand elles se trouvent capille à pic. Loin de ces torrents venant du côté de l'est et dont le volume surpasse celui de tous les autres ensembles, se précipite du haut d'un rocher que s'avance en saillie, et tombe avec un brut horrible à plus de 1200 pieds de profondeur. Ces eaux, divisées dans les airs et réduites comme en poussière, forment autour de la cascade un brouillard suspendu que dérobe aux du spectateur tout son volume et la vitesse de ses chutes. L'urine se réunissant tout ces eaux et commence le gave, est de forme irrégulière. Sa surface inégale offre tantot de grands plateaux de neige, de blocs de rochers écroles et d'autres débris advenus et réduits à l'état terreuse aux végétants de belles plantes que le soleil éclaire à peine. Le gave, en tombant sur les amas de neige, creuse un gouffre au fond duquel le soleil avant son déclin peint le cercle color de l'iris. Les eaux disparaissent sous la neige et renaissent en soute comme sous un pont étroit au sous la voûte d'un aqueduc, elles serpentent, se repliant à travers les ruines amoncelées, et surmontant les obstacles que s'opposent à leur sortie. Si l'aspect magnifique et la beauté sauvage de cet enceinte sont difficiles à représenter, sa structure en est pas moins facile à saisir. Et dans ce lieu, que semble fait pour le tourment du peintre de la nature, se découvre sans peine au lieu de l'observateur et de l'historien. La grande enceinte de la cascade de Gavarnie, dit-M. D'Arcet, fut un lac autrefois, l'aspect de le fait naître naturellement cette idée. Dans la suite les rochers que la formoyent sur le devant, s'étant détruits, les eaux se sont écoulées et produisent. On n'y peut se refuser à croire avec M. D'Arcet, que l'enceinte de cascades de marbre en était autrefois un lac. Le nombre et l'étendue de ces amas do diminuant tous les jours dans les Pyrénées comme dans tout pays de montagnes. Les eaux que viennent sy rendre en exhausant le fond par les cailloux et les débris terreux qu'elles y entraînant, et celles que s'écoulant en abaissant le niveau, en creusant insensiblement le canal par lequel elles sortent. Ainsi la marque lente et progressive de la nature sans l'intermédiaire d'accidents et de révolutions, suffit pour combler ces vastes creux ou les eaux se sont amassées, ou pour ouvrir de issues que n'y leur permettent plus dy séjourner. Le nombre de ces lacs abandonnés et produits n'est guère au-dessus de celui de lacs encore existants. Les naturels du pays ont appris eux-mêmes à distinguer ces monuments naturels. Ils ont saisi leur structure semblable à celle d'un vaisseau évasé et coupe dans ses parois d'une eau de plusieurs intelles profondes, et les ont tout designs par le motiao, que derive du mot latinal, et signifie chez us marmite. Comparaison aussi juste que peu noble et bien digne de ces observateurs Freud's, mais exacts, également dépourvu de prévention et d'enthusiasme. Ces aussi trouvant souvent places aux extrémités supérieures de vallées, à l'origine de torrents que les remplaçaient autrefois. En effet, ceci naissent communément sous quelque vaste amas de neige, aux équivalent d'un réservoir que rassemble les eaux de hauteurs voisines. Le nombre de ces lacs augmente à mesure qu'on s'élève, et c'est une observation générale, que ceux de vallées sont pour la plupart comme aux produits, et que ceux de montagnes, surtout de celles de granit, sont presque tout conserves. J'ai dit précédemment, d'après l'observation de M. Darcy, que l'ensemble de cascades présentoit la forme d'un réservoir introvert et épuis, et qu'elle était précédée d'un autre bassin dont l'aspect est moins sauvage et la forme plus régulière. Tout porte à penser que celui-ci a été aussi longtemps rempli d'eau, ou plutôt il résulte d'un examen détaillé de ces l'eau, que le deux bassins en faisaient autrefois un seul et immense réservoir. Les eaux étoyant retenues à deux ou trois cents toises d'élévation au-dessus du sol ou elles coulent aujourd'hui. Les rochers que séparent le premier bassin de l'ensemble de cascades en sont, comme j'ai déjà remarqué, un vaste amas de débris. Mais ces débris en ressemblant point à ceux d'une muraille renversée sur elle-même, ou d'une digue rompue par l'effort de eaux. Il est au contraire de se convaincre qu'ils ont été détachés de cette partie de la montagne que borde l'ensemble du côté de l'est, et sur lequel sont les sommets les plus élevés de toute cette masse. On voit encore sur ces flancs d'échers pendre d'énormes quartiers de roches prêtes à s'écrouler. Ce que sont déjà tombes ont demeurent intasses les uns sur les autres. Lamas ils ont forme estadas à la montagne dont ils faisaient jadis partie, et s'inclinent jusqu'aux parois opposées de l'enceinte. Le torrent que la traverse s'y trouvé ainsi rigide du côté de l'ouest, et le lit il accrue sous les contours de ces amas de débris. Un temps donc existe aqua les deux saints dont j'ai parlé, étant remplis d'eau, en formoyant un seul lac vaste et profond. Et peut-être la même révolution que les sépares ATL change tout à fait leur forme et cause l'entière dispersion de leurs eaux. Car si l'on considère que l'enceinte du bassin de la prairie est entièrement détruite du côté du nord et de la vallée, on doit s'y convaincre que les eaux en éloignent point corrodé lentement. Mais qu'elles éloignent introvert et emporté par un effort violent et subit. Or à quelle cause peut-on mieux attribuer le mouvement rapide et le choc que de les agiter, tuer la chute instantanée de plusieurs milliards de toises cubes de rocher. Je me représente alors ces lacs paisibles et élève change en un mercurci, SESOs bouleversés jusqu'au fond de SES abîmes jailer au-dessus de sommets voisins. Et retombant sur elles mêmes ébranler de leur poids et de leur chute la barrière que les retenoit, cette barrière trop foible enfin renversée et SES débris transportés au loin. M. Darcy, dans son discours sur les Pyrénées, présage la même révolution pour le lac d'Escobans le plus considérable de ce que dominant les bains de Bareges. N'y peut douter que si quelque éboulement considerable vint hater et accroître l'effet de cette débâcle inévitable, ces regions élevées subiront un nouveau déluge dont les hommes et les troupeaux seront la victime. Que ensevelira plusieurs villages, et inondera les tanières de bêtes fauves. M. Reboul has here imagined to himself the former existence of an immense deep lake, which, no doubt, is a thing that may have been, like many others which actually exist. But then he likewise supposes a particular revolution of things, in which one side of that stony circuit, forming the basin of the lake, had been destroyed while the water was discharged. It is this last hypothesis which appears to me to be a thing altogether inadmissible, according to the natural order of things. In order to see this, it must be considered, that the side of the basin, which has disappeared, must have been either of similar materials to those which we see now remaining, or it must be supposed as composed of loose materials, such as had been more soft, or of those that might be easily dissolved and washed away by the water. If this last had been the state of things, there would not have been occasion for any violent catastrophe, as M. Raboul has supposed. The natural overflowing of the lake had been sufficient to wear the mound by which the water had been detained, and to carry away those materials so as one side might disappear. If, again, this mound had been formed of rock, like what remains of those mountains, in that case, the catastrophe, which this author has suggested as the cause of that destruction, would have been ineffectual to procure that end. For, though such a debacle might have carried away a great mass of loose materials, it could not have moved a mound of solid rock. That of which we have here undoubted information, and that which I am laboring to generalize by comparing similar phenomena, such as are to be found over all the earth, is this: that the natural operations of the atmospheric elements decompose the solid rocks, break down the consolidated strata, waste and wash away those loosened materials of the mountains, and thus excavate the valleys as the channels by which an indefinite quantity of materials are to be transported to the sea for the construction of future continents. It is this operation of nature which we see performed, more or less, every day, which some natural philosophers have such difficulty in admitting at all, and which others overlook in seeking for some wonderful operation to produce the effect in a shorter time. The prodigious waste that evidently appears, in many places, to have been made of the solid land, and the almost imperceptible effects of the present agents which appear, have given occasion to those different opinions concerning that which has already happened, or that natural history by which we are to learn the system of this world. The object which I have in view, is to show, first, that the natural operations of the earth, continued in a sufficient space of time, would be adequate to the effects which we observe. And, secondly, that it is necessary, in the system of this world, that these wasting operations of the land should be extremely slow. In that case, those different opinions would be reconciled in one which would explain, at the same time, the apparent permanency of this surface on which we dwell, and the great changes that appear to have been already made. Now if, in the indefinite course of time, which we cannot refuse to nature, and which is only to be traced in those effects, the chemical and mechanical operations of the surface are capable of diminishing the mass of land above the level of the sea, of which fact the appearances here so well described by M. Raboul, and those which are everywhere else to be observed, leave no room to doubt. And, if the wise system, of a world sustaining plants and animals, requires the long continuance of a continent above the surface of the sea, what reason have we to look out for any other causes, besides those which naturally arise from that constitution of things? And, why refuse to see, in this constitution of things, that wisdom of contrivance, that bountiful provision, which is so evident, whether we look up into the great expanse of boundless space, where luminous bodies without number are placed, and where, in all probability, still more numerous bodies are perpetually moving and illuminated for some great end? Or whether we turn our prospect towards ourselves, and see the exquisite mechanism and active powers of things, growing from a state apparently of non-existence, decaying from their state of natural perfection, and renovating their existence in a succession of similar beings to which we see no end. We have been comparing similar operations of nature in different countries, but at present we have something farther in our view than to compare the distant regions of the earth. We want to see if it be the same system that is observed in the higher regions of the globe as in the lower. We shall thus have investigated the subject as far as we can go. The high region of the Andes and Cordilleras affords an opportunity of deciding that question. It is there that we find a habitable country raised above the rest of the earth. It is there that nature, in elevating land, has proceeded upon a larger scale. Here, therefore, in the operations of water upon the surface of the earth, we are to look for effects proportioned to the cause. Let us cast our eye upon the southern continent of the New World. There is not, from the one end to the other, any great river that flows to the sea upon the west side. A ridge of mountains, at no great distance from the coast, divides the water of this continent. A small part runs to the west, the most part runs to the east. and forms a country which, for fertile plains and navigable rivers, has not its equal upon the globe. But let us observe the course of the rivers, while confined by the ridges of the Andes and Cordilleras. They run either south or north, and are thus for some time constrained to take a course very different from that which they are afterwards to pursue. It is while thus retained within the ridges of the Andes that those rivers water plains which they had formed. And it is here that we find countries so much elevated above the rest of the world, that, under the direct rays of the sun, their inhabitants are made to suffer from the cold. It is the collection of those waters running from south to north, and descending from an enormous height, that have formed in the plain those appearances that struck so much the French philosopher, as to make him give us a detail, which, though out of his line, is extremely interesting in the natural history of the earth. It is in the valley of the Magdalena that M. Bugger found those grand relics of the wasted strata, but we are now to take a view of a country situated high above the level of that valley. It is that of Santa Fe de Bogota. A fertile plain estimated at 1,600 toises, almost about 2 miles above the level of the sea, and which pours its water into the valley of the Magdalena about a degree above Honda, which is mentioned by M. Bugger as giving so fine an example of those water-worn rocks. The extreme singularity in the situation of this country, and at the same time the perfect similarity which is here to be observed of this country with all the rest of the earth, as the work of water, will excuse my transcribing from M. Le Blond, Journal de Physique, my 1786, what I judge to be interesting to my readers. Si un observateur attentif parcourt les plaines immenses de l'Amérique méridionale, sal monti les fleuves rapides et profonds que les traversent, et les inondant, et sal franquit les montagnes prodigieuses que l'action de eaux de trout. Il apercevra bientôt un développement successif et inévitable de ce nouveau continent tend à élegrander dans tous les sens, et de rendre peut-être un jour sa surface égale à celle de notre hémisphère. Il est de sites dans les montagnes de cordilleras au lieu de obstacles plus au moins puissant retardant cette même dégradation, la plaine de Santa Fe de Bogota est entre ces sites celui que me paraît le mieux caractérisé et le plus frappant. Il sera l'objet de ces mémoires, on verra avec surprise un pays sain, agréable, abondant, et fertile aujourd'hui, était autrefois le plus dépourvu et le plus misérable du monde. Ou l'Indien malheureux envoie pour tout bien que de rivières sans poissons, de oiseaux en petit nombre, en quadrupède au du, et de quelques légumes. On sera éton d'apprendre qu'une température froide environnée d'un climat brûlant, fait un barrière insurmontable pour presque tous les animaux et les plantes de pays chauds. La nature agresse et avoir de ses dans sembloit en regitre home, et vouloir y être en quelque sorte séparé du reste du monde par de rochers énormes, coupes verticalement. Qu'on any parvient à franchir avec de difficultés étranges à travers un brouillard humide et ténébreux, que persuade aux voyageurs fatigues il traverse la région de news. Arrivé au haut de ces montagnes, un nouveau ciel, un nouvel ordre de choses s'y présentent, c'en sont plus ces insectes dégoûtants et insupportables que le fatiguant sans relâche, ces reptiles venimeux, dont il reditoit la morsure. Ces bêtes féroces toujours prêtes à le dévorer, enfin, c'est, chez le suffocant de l'obéis il vint de quitter, l'air il respire refraquet et le vivifie, il esserit, ece que l'environ eleton et le ravit. Sil regardo decis de lui, tout est éclipse par de nuages, dont la surface égale mevant lui représente un mer habite le silencide que termine son horizon. Sil jette la vue sur la plaine que se per devant lui, les news il croyait sous ses pieds, roulant majestueusement sur sa tête, de nouvelles montagnes s'élevant de toutes parts, et formant un nouveau monde que paroit indépendant du premier. Pour donner une idée exacte de ce pays singulier, j'ai cru devoir transporter le spectateur à la capitale, au de la comme d'un centre Illinois peut observer plus commodement les phénomènes que j'ai à lui présenter. La ville de Santa Fe de Bogota, capitale du nouveau royaume de Grenade, à environ 4 degrés de latitude and, et 304 de longitude, prise de l'île de Fer, est situé au pied sur le penchant d'une montagne escarpée que la couvre à l'est. Elle domine un plain de 2 lieues de largeur sur une longueur indéterminée et très considerable, que présente tout l'année le riant tableau de plus belles campagnes de l'Europe, les coteaux toujours verts ou les troupeaux bondissants. Les prairies couvertes de bétail, les champs bien cultivés, les maisons de campagne agréables, les hameaux, les villages, les vergers, les jardins, montrant à la fois, les fleurs du printemps et les fruits de l'automne. Que l'abondance de pluies ou les sécheresses retardent ou avancent quelquefois mais dont l'éternel durée bien loin d'inspirer le plaisir, et d'y offrir le trait piquant de la nouveauté que fait le charme de ces saisons dans nos climats. Amin bientôt l'indifférence pour un but toujours le même, pour de agréments que n'y changent pas. Ce climat est d'alors si étrange et tellement constitué, que quand on est au soleil, on s'y trouve bientôt incommode de cela, est en à l'ombre. On s'y sent pénétrer d'un air subtil et froid que transit. À 3 lieues et peu près à l'ouest de la ville, passez la rivière de Bogota que, après avoir recu les eaux de toute la plaine, la rivière de Serafula et les torrents que s'y précipitent de la chaîne de montagnes. Dirige son cours paisible vers Tequendama à 7 ou 8 lieues au sud-est et peu près. Si est là que ces eaux rassemblées coulant entre une suite de rochers granitiques, dont le plain incline accélère leurs vitesses. Elles en offrent bientôt plus un courant rapide, étroit et profond que, au moment de sa chute, rejaillit sur un rocher place plus bas que sunlit, d'où tum don un abîme dont on n'a pu jusqu'au ici measure la profondeur. C'est la cataracte au saut de Tequendama. Des trous pratiques dans le roc par les anciens aux endroits les plus commodes pour voir tout l'étendue de cette chute prodigieuse. Donnant le moyen d'y observer sans risquer la continuation de rochers que s'avancent à droite et à gauche et annoncent par leurs hauteurs avant le passage que les eaux semblant avoir force. La plaine de Santa Fe était alors un lac d'une très grande étendue, une tradition constante du pays, mais peu vraisemblable, pour que les Indiens ont creusé cette espèce de canal. Il y a quelques uns de ces trous d'où l'on voit confusément le lieu finit cette chute d'eau effroyable. La rivière que en provient en offre plus un foible ruisseau, dont le cours presque insensible s'y perd parmi les plantes que croissent sur ses bords. Ainsi disparaissent dans l'éloignement les masses les plus énormes, quelques espèces de paraquets et d'autres oiseaux de pays chauds, que habitent cette vallée profonde et inabordable de ces côtés. S'élevantes quelquefois pour pouvoir être remarques d'enote. Mais le froid subit de ces montagnes ils craignent, est un obstacle invincible ils infranchissent jamais, pour jure commodement de ces points de vue, à la fois admirable et effrayant Illinois faut choisir un jour comme il serein. Entre sept à 8 heures du matin. Il est nécessaire de prendre un long détour et cheminer pendant toute une journée, presque toujours à travers de rochers et de précipices, pour parvenir au pied de cette cataracte. On est alors étrangement surpris de voir que cette rivière à peine sensible d'en haut, soit encore un torrent prodigieux, dont la chute en cascades dans un angle de 45 degrés. Offre pendant l'espace d'une grande demi-lieue de amas de rochers entassés au hasard, que frappé et détruit sans relâche le plus brillant conflict de eaux. C'est après cet espace que le courant, devenu plus paisible permet encore de comparer la rivière de Bogota à ce chuist la Seine dans l'élite. Un phénomène bien extraordinaire et que cert en même temps à donner la plus haute idée de l'étendue prodigieuse de cette cataracte, c'est que sa chute commence dans un pays très froid où il geli souvent pendant la nuit. Et finit dans un autre où la chaleur, égale à nos beaux jours d'été, offre la végétation prompte et facile de toutes les plantes de pays chauds, seroit le passage subit de l'air du chaud au froid que occasioneroit ces gelis blanches. Et plus pres comme celles que ont lu dans nos climats aux approche de l'hiver et à l'entrée du printemps. Car on en éprouve rarement dans la plaine. Un autre particularité remarquable de ces pays, c'est le défaut de poissons dans toutes les rivières que elles on en trouve cependant dans celle de Bogota ou les autres rivières viennent s'y rendre. Mais c'est une seule espèce très peu abondante, que les Espagnols appellent el capitán, ou le capitaine, la plus grande longueur de ces poissons est d'environ un pied, sur 6 pouces de grosseur. Il vit dans les eaux troubles et uses de cette rivière, et jamais dans les eaux claires, il est gras et excellent à manger, son genre est celui de l'amistel fluviatile de France et le Gades de l'Inn. Il est certain cependant que les poissons de toutes les sortes abondent dans les grandes rivières de l'Amérique méridionale et notamment dans celle de la Magdalene. Ne pourrait-on pas supposer d'après cela, que puisque toute communication de eaux de tout le pays élève de Santa Fe est interrompue avec cette dernière par le saut de Tequendama. Ces mêmes eaux n'ont en être pupilles comme celles-ci paroissent avoir été, au moins en partie, par la mer. Ce même défaut de poisson s'y remarque dans la plus part de lacs et de rivières de cordillères, probablement par une cause semblable. Il en a point dans les deux lacs ces étendues que sont près de la ville d'Ihavara dans la province de Quito, non plus que dans les rivières de la province de Pastos. On peut objecter qu'une une température toujours froide comme celle de Santa Fe, joint à la limpidite et la rapidite de torrents de cordillères, suffisante pour écarter les poissons, de même que cela arrive dans plusieurs rivières de l'Europe. Cette objection serait vraie pour la plupart de torrents de cordillères, mais on observera que la rivière de Bogota quoique froide, est presque stagnante dans bien de endroits, et coule toujours sur de la vase que en rend les eaux borbeuses. Il est à présumer que, s'il était possible d'y transporter de poissons de nos rivières, ils y réussiront aussi bien que les autres productions de l'Europe que s'y sont naturalisées dans ces pays. Quant à la température constante froide de ces eaux, que pourraient s'opposer au développement de œufs du poisson que habitent les rivières de pays chauds, on y répondra par le fait suivant. Avec les environs au nord de Santa Fe à la même élévation et à la même température, est un grand lac où l'on trouve de îles habitées et que en apparut assez grande pour être indiqué dans les cartes géographiques. Si on en savoit les dimensions. C'est le lac de Chiquinquira assez poissonneux pour y faire de pêches abondantes, parce que la rivière que en sorte n'est pas interrompue par de sauts dans son cours jusqu'où la rivière de la Magdalene. Cependant les espèces de poissons qu'on trouve dans ces lacs n'y sont pas aussi variées que dans cette grande rivière, sans doute à cause de la rapidité du courant, que le poisson n'y remonte pas également bien. Lorsqu'on gravite sur les montagnes escarpées que dominent la ville de Santa Fe, on y rencontre, depuis leur base jusqu'où leurs sommets, termines par de rochers de granit, que de bruyères, de faugères, quelques plantes sauvages, etc. Il pas un arbre qu'on puisse seulement appeler un buisson except dans quelques gorges à l'abri de courants d'air, où l'on en voit quelques uns dont les plus grands, n'égalent pas nos pruneurs. Cette végétation engourdie paraît être due au froid vif continuel qu'il fait sur ces montagnes. Car plus on monte, moins lsi développe. Et enfin finit par cesser tout effet, on remarque à la moitié de la hauteur d'une de ces montagnes, à un demi-lieu à peu près de la ville, un mine de charbon de terre en filin que renferme un rocher entrevert, dans une situation verticale 27. Les torrents y roulant de l'or. Footnote 27, return, here is an evidence that those vertical strata, now elevated into the highest stations upon the earth, had been formed originally of the spoils of the land, and deposited at the bottom of the sea. Si l'on descend dans la plaine, si l'on remonte sur les collines, Touts et poupres de la même hauteur que sont entièrement séparés de montagnes voisines, et situées dans la direction au courant de rivières. On remarque mentuels sont les restes d'une plaine antérieure que les eaux ont dégradé. Au lieu de ces forêts, et de ces boissons que surchargent bientôt nos campagnes lorsque la main de l'homme cesse de les cultiver. Un gazon touffu couvre la plaine et les collines de Santa Fe d'une verdure agréable sans nul arbrisseau que puisse en alter el uniformite, o les graminées, le plantain, le scorconaire, le trèfle, le marroube, la pimpernelle, le pourpre. La patience, le chardon, le raifort, le cresson, la chicorée sauvage, la jonquille, la marguerite, le fraisier, la violette, le serplet, le thym, et mille autres plantes d'Europe et particulières à ces pays. Offrant les variétés les plus piquantes par la beauté de fleurs et l'odeur de leurs parfums. De rochers entourant le rosier au la ronce, et quelques cavernes que le hasard présente sur ces mêmes collines, en rendant l'aspect pittoresque et delicieux. Here is a picture of a country such as we might find in Europe. Only it is placed under the line, and elevated above the highest of the frozen summits of the European Alps. We may observe that the same order of things obtains here as in every other place upon the surface of this earth. Mountains going into decay, plains formed below from the ruins of the mountains, these plains ruined again, and hills formed in their place, rivers wearing rocks and breaking through the obstacles which had before detained their waters. And a gradual progress of soil from the summits of the continent to the border at the sea, over the fertile surface of the land, successively destroyed and successively renewed. Here are to be observed two states of country alongside of each other, the plain of the Bogota, and the valley of the Madalena. The courses of the two rivers show the direction of those ridges of mountains which have been raised from the deep. They run south and north, as do those valleys which they drain. At this place we find the valley of the river Cauca, and the valley of the Magdalena parallel to each other, and also to this high plain of the Bogota. Now the waters of this high country, instead of running northward to the sea, as do those of the two valleys below, run both from the south and north until, uniting together, they proceed westward, break the rampart of granite rocks at Tequendama, and fall at once from the high plain down into the valley of the Madalena. Those water-formed plains which we perceive subsisting at unequal levels immediately adjoining to each other, while they present us with a view of the degradation of the elevated earth. At the same time illustrate the indefinite duration of a continent. For, we judge not of the progress of things from the actual operations of the surface, which are too slow for the life of man, and too vague for the subject of his history, but from the state of things which we contemplate with a scientific eye. And from the nature of things which we know to be in rule. In like manner the horizontal situation of the solid strata in the mountains of that low country, while those of the high country are more or less inclined, afford the most instructive view of the internal operations of the globe. By which the Andes have been raised from the bottom of the sea, and of the external operations of the earth by which mountains are formed by the wasting of the elevated surface. With this description of those high plains upon the north side of the line, let us compare what D. Aloa has said upon the same subject in describing the continuation of that high country to the south. I shall give it from the best French translation. It is after describing a cut or narrow ravine in the solid rock with perpendicular sides, about 40 yards deep, in which a rivulet runs and the road passes. Cette excavation est, en petit, un modèle de vastes quadratus aux profondeurs, et fait comprendre leur origine, elles en y pouvoient être que semblables à celle-ci, tout y est passé de même, ou plus tard ou plus tard. Les flancs en ont été plus aux moins perpendiculaires, jusqu'au moment où ils sont affaissés, et ont forme de plaines inclines, lorsque l'eau faisant de plus profondes excavations, yet mine la base que les soutenait. Ne pouvant plus alors persévérer dans leur premier état, les terrains ont creux, et ont pris l'inclinaison ils ont conservé depuis. La même chose arrivera nécessairement à ce passage de connaître lorsqu'avec le laps du temps, les effets de pluies, de gels, de rayons solaires, auront fait tomber en ruine ces parois, quoique de roche rive. Car ses agens puissance font sentir leur énergie aux corps les plus durs. Ainsi les boards du chapelain casperdront insensiblement la régularité de leur distance, de leurs côtés rentrants et salons, après elle avoir peut-être conservé plus long temps que d'autres excavations, parce que c'est un pierre dur. Que n'est mêlé d'aucune veine de terre mouvable. Nous pouvons le croire sans hésiter, car si n'est que le seul frottement de l'eau que a excave si lit jusqu'à la profondeur chuil a. Mais le temps, que réduit les roches les plus dures en sablon, ira toujours en élargissant la partie inférieure, par son action continuelle et insensible, aussi voit on ce ruisseau rouler de petites pierres que se détachent sous les eaux. Comme on en apercoit dans la plaine au il les entraîne, en sortant de la montagne, pour se décharger dans un terrain plus spatieux. Que canal a été excave à cette profondeur par l'effet continuel du frottement de eaux, ou chuil a été ouvert par un séquence de tremblement de terre que fit fendre la montagne, de sorte que le ruisseau que couloit d'un autre côté. Se soit jeté de celui-ci. Il est certain que cette ouverture profonde est postérieure à l'arrangement que les terrains eurent après le déluge. Et que c'est ainsi que ces énormes quebradas de la partie méridionale de l'Amérique, se sont formées avec le temps, par le frottement du cours rapide de eaux. En effet, on observe que la force avec laquelle s'éclatent toutes les eaux de cette partie du globe, suffit pour arracher de roches d'une masse extraordinaire. C'est pourquoi l'on voit en certains parages de marques évidence de leurs excavations profondes au milieu même de lits de ces eaux. Ce sont des cubes d'une grandeur énorme, que n'ont pu être détachés avec la même facilité que les parties contiques. La rivière d'Escatbaca, que coule près d'un hameau de même nom, nous présente dans son lit un de ces masses, dont la forme est précisément celle d'un cube. Lorsque l'eau est basse, ce cube s'élève à sept ou huit varas au-dessus du courant, chaque côté porte deux varas de face. Mais ces masses, et autres moindres de différentes formes, que se voyant dans les eaux, n'y peuvent être arrivées à cet état, sans que l'eau les ait dégarnies peu à peu de pierres, de sables que les enveloppent. Et chuel a arraches de tous côtés pour les laisser isolés. Or elles se maintiendront dans cette position, jusqu'à ce que les eaux, que vont de plus en plus, rencontrent enfin à la base de veines de matters friables et dissolubles, qu'elles pénétreront et qu'elles emporteront. En détruisant l'assiette sur laquelle posent ces masses jusqu'alors immovables. Un creux d'eau considerable, et que n'y laissera plus paroître chuan varas de cette masse, pourra dans ce temps la l'arracher, et la faire rouler. Mais ce mouvement, et les chocs chuel éprouver de la part d'autres masses moins grosses, souffrent pour en briser les parties saillantes, et la réduire en parties moins volumineuses, que rouleront avec plus de facilité. Et que par cette seule cause diminueront encore. C'est à cette cause qu'on doit attribuer ces quantités prodigieuses de pierres répandues et sur les bords de ces eaux, de même que ces roches énormes qu'on voit détachées, et que jamais les forces humaines n'auraient pu mettre en mouvement. Mais pour donner une idée quelconque de la profondeur de ces excavations, relativement au terrain au sol habitable de la partie haute de l'Amérique, il est à propos de rapporter quelques expériences. Guancavelica est un bourgade, ou un corps municipal, situé dans un de ces profondeurs, forms par différentes suites d'éminences. Le mercure du baromètre y descend, et serait à 18 pouces en ligne et demi. Sa plus grande variation y est de 1,25 à 1,75. Sa hauteur est donc de 1949 toises, ou 4536-2/3 varas au-dessus du niveau de la mer. Au haut du mont OSE trouvé la mine de mercure, mont que est habitable partout, et que est immédiatement surmonté par d'autres, Hutton chuil s'élève au-dessus de Guancavelica, le mercure descend ets arit à 16 pouces 6 lignes. Sa hauteur est donc de 2337-2/3 toises, au lieu de 5448 varas au-dessus du niveau de la mer. Ainsi les eaux ont encore fait cette autre excavation comme il est facile de le voir par des indices manifestes. On remarque en effet dans la partie voisine de leur lit, de roches détachées, tout semblables à celles que sont au milieu de eaux. Ce que prouve que les eaux ont été au même niveau à une époque beaucoup plus ancienne, et qu'elles ont excavé le sol, à force d'enrichir les parties agrégées. Ces terrains sont couverts par un assez grand nombre de courants, chuil nn est aucun ou elon nn apercoive, soit don de ravens, soit entre de montagnes. J'ai observé que la superficie de terrains que en avoisin les lits, est plus uni aux confluens, au plusieurs de ces courants se réunissent. C'est le vent de ces que l'éminence, que se trouve au confluent, pourrait avoir été diminué à la partie où elle a dû former un point salient, à mesure que les eaux l'ont rongé de l'un au de l'autre côté, en continuant leurs excavations. Ces surfaces planes sont comme par étages, les uns plus hauts que les autres, et sont insensiblement formes, silen que l'os est plus ou moins arrêté à différentes hauteurs, pendant qu'elle croissoit ces lits. On observe, au contraire, que les bords élèves dans ces courants, en presque point de largeur dans les endroits où l'eau a pu suivre son cours très directement. C'est cependant sur ces bords étroits et escarpés que se trouvent pratiques les chemins par où elles ont passé. Le danger y est très grand, car à peine un animal peut-il poser le pied. Toutes les fois que le courant fait un détour, la surface de bords a plus de largeur, cependant moins que lorsque plusieurs se réunissent. On voit facilement pourquoi. L'eau forcée de se détourner, s'éloigne plus de la rive que quand elle va en ligne droite, et range ainsi le côté salient sur lequel elle fait son détour, et que en devient comme le centre. On peut conclure de ce que je viens de dire, à quelle élévation est la partie haute aux montagnes de l'Amérique, relativement à la partie basse, et chuil y a de excavations extrêmement profondes. Car elles ont, comme j'ai déjà dit, 1769-2/3 varas perpendiculaires, au même d'avantages, cependant elles ont assez de surface pour devenir le local de nombre d'habitations fort peuplées, que en tirent tous les produits nécessaires à la vie. Parmi ces quebradas Illinois en est de plus étendues au de moins profondes que les autres. Or, c'est ainsi que cette partie du monde se distingue de toutes les autres. Mais il est indifferent pour mes vues que ces vastes ovaches soyant l'effet de courants d'eau, au de toute autre cause. Ce que je me propose, est uniquement de montrer qu'elles sont d'autant plus profondes et plus vastes, que ces terrains sont immensement hauts. M. Monet considers the natural operations of water, upon the surface of the earth, as truly forming the shape of that surface, but he draws some very different conclusions from those which I have formed. It is in his Nouveau Voyage Minéralogique, fait dans cette partie du Hainaut connu sous le nom de Thierique. Journal de Physique, Aoust 1784. Il ne faut pas s'attendre à trouver dans ces pays de hautes montagnes que frappent la vue de loin. C'est seulement un pays dont l'élévation est générale sur tout ce que l'entoure, et est coup profondément par de vallées au ravin, ouvrage de eaux, que, la comme leurs, ont us et coup pour les terrains et les roches les plus dures. Pour s'ouvrir un passage. Et peut-être pourrait-on dire. Si la diminution de eaux n'était pas trop sensible, tu un jour ces pays offriraient de montagnes hautes est escarpées comme tant d'autres, après que les eaux auront crus, pendant de milliers de siècles, ses gorges, ses ravins. Et diminue la largeur de masses de terrain que sont entre eux. Quant à présent, on any put y voir que de petites montagnes, ou plutot de basses de terre, avec de platures plus ou moins considerables à leurs sommets, avec de côtes capies plus ou moins obliquement, ou plus ou moins droits. Ce qu'on y trouve de singulier c'est que ces petites montagnes sont presque toutes plus basses que les plaines que les avoisinantes, encore any sont elles que dans la partie calcaire. La plus profonde tranchée de ces pays est, sans contredit, celle ou que la mieux, que, malgré la durite de roches d'ardoise et de quartz au travers desquels elle passe, occupe le terrain depuis Charleville jusqu'où Givet. À une très grande profondeur. Dans cette distance, on voit presque partout les côtes capies presque à pic sur la rivière, de 2 à 300 pieds de hauteur perpendiculaire. Et comme c'est une règle générale, que plus les côtes sont capies droits, moins elles sont distantes l'une de l'autre, on concoit que le canal de la Meuse, dans cette étendue de terrain, doit être fort étroit. Eudegard a beaucoup d'autres o il coule un bien moindre volume d'eau. Cela n'empêche pas qu'on ny apercoive de marques de la règle générale que fait l'eau, et ny est taille de angles salins et de angles rentrants, que sont très grands en certains endroits. Nous verrons que ravin et fumai, du le principaux de bords de la Meuse, sont situés sur deux de plus grandes de ces ovaches ose trouvant de platures assez vastes pour permettre, outre un emplacement considerable pour les maisons. L'établissement de beaucoup de jardins, et même de pistes à grain et de prairies. Aussi, quand on arrive sur la tranchée de la Meuse, les lieux et les terrains cultives qu'on voit dans son fond, paroissent comme séparés sous les autres et comme dans un autre pays. Les autres coupers ou ravens de ces pays, quoique moins profonds, offrant cependant cette singularité, remarquée déjà à leurs, que leurs grandeurs et profondeurs n'y sont point du tout proportionnées au volume de l'eau que y coule. Le massif sur lequel est situé Beaumont, est coupe presque perpendiculairement à l'ouest, sud-ouest et cette coupe en fait de ces côtes-là un rempart inaccessibles, ayant plus de 100 pieds de hauteur. Quand je considère cette grande coupe, et le détour que fait la petite rivière que coule au bas de ces massifs, j'nai pus me refuser à croire qu'il ny avoit en la un bien plus grande courant d'eau, que abattu et mine ces massifs. Ny présent avec force. Car on n'y peut supposer, avec quelque vraisemblance, que cet ouvrage ait été fait par le volume d'eau que y coule actuellement, et il n'y faut pas s'étonner de ces disparates, partout vous le trouverez. C'est que démontre évidemment que la quantité d'eau diminue insensiblement, et que la partie solide de notre globe augmente à proportion que la partie liquide diminue. Et il faut encore étendre ces principes, j'ajouterai, que partout vous verrez les bornes de la mer et de rivières reculées. Partout vous trouverez d'anciens courants d'eau desséchés, et même de rivières considérables, à en juger par les collines ondulées qu'on voit encore. Mais cette partie essentielle de la minéralogie que est effrayante par les conséquences qu'elle présente, et que peut influer sur le système général du monde, sera étendue un jour dans un autre mémoire. Je décrirai d'anciens cours de rivières de la France, que n'existent plus. J'espère faire voir alors, appuyé par les faits que me fournira l'histoire, que les rivières et les fleuves actuels ont été plus volumineux qu'ils en le sont maintenant, et qu'il existait en France un grand nombre de vastes lacs. Comme dans l'Amérique septentrionale, et dont à peine il nous reste de traces aujourd'hui. This opinion of M. Monet, concerning the diminution of water upon the earth, does not follow necessarily from those appearances which he has mentioned. The surface of the earth is certainly changed by the gradual operations of the running water, and it may not be unfrequent, perhaps, to find a small stream of water in places where a greater stream had formerly run. This will naturally happen upon many occasions, as well as the opposite, by the changes which are produced upon the form of the surface. Likewise the conversion of lakes into plains is a natural operation of the globe, or a consequence of the degradation of the elevated surface of the earth. Without there being any reason to suppose that the general quantity of running water upon the land diminishes, or that the boundaries of the various seas are suffering any permanent removal. Whether we examine the Alps in the Old World, or the Andes in the New, we always find the evidence of this proposition, that the exposed parts of the solid earth are decaying and degraded. That these materials are hauled from the heights to be traveled by the waters over the surface of the earth, and that the surface of the earth is perpetually changing, in having materials moved from one place and deposited in another. But these changes follow rules which we may investigate. And, by reasoning according to those rules or general laws, upon the present state of things, we may see the operation of those active principles or physical causes in very remote periods of this mundane system. And foresee future changes in the endless progress of time, by which there is, for every particular part, a succession of decay and renovation. Chapter 13. The same subject continued. The Chevalier de Dolomieu, in his most indefatigable search after natural history and volcanic productions, has given us the description of some observations which are much calculated to put this subject in a conspicuous point of view. I give them here as examples of the operation of water wasting the land and forming valleys in a system where everything is tending to the wisest end or purpose. But they are no less interesting as proper to give us a view of the mineral operations of the globe. That therefore which, according to the order of the subject, ought to be cited in another part of this work, is here necessarily mixed in the narrative of this natural historian. There is, upon this occasion, such a connection of the facts by which the mineral operations of the earth, either consolidating the materials deposited at the bottom of the sea or elevating land by the power of subterraneous heat, are to be understood, and of those by which the operations of the surface are to be explained, that while they cannot be separated in this narration, they throw mutual light upon each other. It is in his memoir sur les volcans éteints du Val di Noto en Sicile. Journal de Physique, September 1784. J. Travail les premiers indices de ces volcans, en allant de Syracuse à Sortino, un le de cette ville, au fond du profond vallon que y conduit. Quelques morceaux de laves entraînés et arrondis par les eaux émanantes d'avance que j'allois entrer dans un pays volcanique. Mon attention est fixe bientôt après sur un courant de laves que j'ai vis sortir d'une montagne calcaire que etoit sur ma droite, Illinois etois coupe par un vallon dont les eaux colloyant sur un sol calcaire. Etioloit est perdré dans le massif également calcaire que etoit sur ma gauche. J'ai passé ensuite alternativement sur de matters calcaires et volcaniques, pour arriver à Sortino, Bill Baronel bâti sur un montagne calcaire que domine le vallon, et que lui présente des escarpements de plus de 200 toises d'elevation. Dans lesquels les bancs de pierres dures sont horizontaux, et exactement parallèles. Here, it is to be observed, are horizontal beds remaining, which give a measure of what had been abstracted by some cause, which is our present subject of investigation. The Chevalier proceeds. Les environs de Sortino m'offrent de phénomènes et de singularités dont l'explication me paraît difficile, et que tinrent pendant longtemps mon esprit en suspens. J'ai vis d'abord les matters volcaniques ensevelies sous de bancs horizontaux de pierres calcaires, très coquières, contenant surtout un infinite de madreporites, quelques uns d'un volume énorme. J'ai vis ensuite de hauteurs dont les sommets sols étoyant volcaniques, et les noyaux calcaires, sans que les laves que cournoyant ces sommets eussent communication avec aucun courant. Et eussent d'autres étendues que le plateau qu'elles recouvrent. Ces laves envoyant pu être formes au j les voies, elles étoyant venus d'ailleurs, mais d'où comment. Etc. J'ai me déterminé à consulter les montagnes les plus hautes, que étoyant à quelque distance. Gen vis de loin plusieurs dont la fermi étoit à peu près conique, et dont les sommets étoyant pointus. Elles étoyant vers le nord, au nord-ouest de Sortino, dans la direction de l'Etna, que terminoit mon horizon, à une distance de 13 ou 14 lieues, etc. La Montagne Saint-Georges, un de plus hautes de tout le canton du sommet de laquelle j'ai pouvoir prendre une idée topographique de tout le pays, que domine tout ce que entoure, à l'exception de quelques pics calcaires que lui sont au sud. Tel que celui de la montagne de Bouwan, cette montagne, dis dont la forme est conique, et que est isolée par de vallées, dont le sol lui etoit surabise de 3 ou 400 toises, à sa base calcaire. Sur cette première assise repose une couche volcanique, ensuite une autre tranche volcanique calcaire, à laquelle succède un sommet forme d'une lave dure. Un autre montagne offers du fief de la Capodia, également conique, est tout volcanique, à l'exception d'une couche de pierre calcaire dure et blanche, que la tranche à moitié hauteur parallèlement à sa base. Quelques montagnes aux les couches volcaniques ou calcaires sont plus ou moins nombreuses. La montagne de Pamelia est volcanique à sa base et calcaire à son sommet. Et enfin la montagne isolée sur laquelle est bâtie la ville de Cariantini est moitié calcaire et moitié volcanique, mais ici la division de deux substances est faite par un plan vertical, etc. Après être arrivé à cette limite de volcans, dont j'ai poursuivi le foyer, j'ai pris du côté de l'est, j'ai suivi jusqu'à Melilai les hauteurs que accompagnent la vallée de Lentini et que dominent la plaine d'Auguste. Et caminant à mi côté j'ai vis déboucher du milieu de montagnes calcaires, que, réunis par leur base, en forment un même groupe, sous le nom de monts Hyblines, cols Hyblii. Plusieurs courants de lave que se terminent comme sils avoyant été coupes sans avoir eu le temps de descendre dans la vallée, et de s'incliner pour en prendre la pente. Plusieurs de ces courants sont cristallisés en basaltes prismatiques, en envoie de très belles colonnes auprès de Melilai. Au-delà de cette ville jusqu'à Syracuse, on envoie plus de traces de volcans, et les escarpements en face du golfe d'Auguste en offrent un massif calcaire en banks horizontaux, etc. J'ai revins à Sortino, Etienne allant visitor l'emplacement de l'ancien herbecis, connu maintenant sous le nom de Pentarica, j'ai traversé du gorges d'une extrême profondeur, dont les encasements, tails presque à pic. Ont plus de 600 pieds d'elevation, etc. The Chevalier then found, in the mountain of Saint-Avenir, an extinct volcano. And proceeds in his memoir to give some explanation for those appearances, as follows. Je n'ai pas doubter que cette montagne fut le volcan que j'ai cherchois, et que avoit répandus ses laves à un très grande distance autour de lui. Surtout dans la partie de l'est. Mais il me restoit à résoudre le problème de la formation de montagnes isolées et coniques, mi parties volcaniques et calcaires, que n'y tenant à aucun courant, et que semblant en avoir aucune relation directe avec mon volcan. L'étude de la montagne Saint-Avenir, et de pays circonvoisins, m'apprit que ce volcan situé élève au milieu de la mer qu'alors occupoit nos continents, que sa tête seule situé sur la vie au-dessus du niveau de eaux. J'ai fus convaincu que, lorsqu'il répandait autour de lui de torrents de maters enflammés, la mer entassoit de dépôts calcaires, que chaque nouvelle éruption trouvoit un sol plus élève, sur lequel elle se répandait. Que bientôt les nouvelles maters volcaniques étoient ensevelies sous de nouveaux dépôts, et ainsi, par l'entassement successif et irrégulier de produits du fouillis de dépôts de l'eau, s'étoient forme un énorme massif, à sommet aplatí et horizontal. Ce massif occupoit tout le centre du Val di Noto, recouvrait de plusieurs centaines de toises le sol sur lequel s'étoient répandus les premières laves, et fut divisé, morceau et dégradé par les courants ou par le ballottement de eaux. Lors de la grande débâcle de la catastrophe que changeait l'emplacement de mers. Les vallons et les gorges que se forment au milieu de ces masses, séparant les laves de la montagne à que elles appartenuient, couprant les courants, et fécondant, avec les débris de ces massifs de montagnes de toutes les formes. Mais la majeure partie conique, ainsi qu'on peut le voir journalement, lorsque, dans un terrain argileux et submerged l'eau, se retirant avec précipitation, excave partout aux els trouver moyens de résistance. Creuse les premiers cylindres tuelles à traces et fermées de petits cônes, dont les sommets sont à la hauteur du sol sur lesquels reposoyant les eaux. Les parties aux les laves avoyant coulent successivement dans la même direction, les uns au-dessus de autres, ont dans naissance aux montagnes dans lesquelles les couches volcaniques et calcaires se succèdent parallèlement. Celles sur lesquelles aucunes laves ne sont portées, n'ont produit que de montagnes totalement calcaires qui se trouvent entremêlées avec les autres. Celles enfin sur lesquelles le hasard au lieu de circonstances locales out en tasse de préférence, et dans le même lieu, les matters que vomissoit le volcan, sans laisser le temps au dépôt de eaux de se mêler avec elles. Ont produit quelques petites montagnes presque entièrement volcaniques, aux les cendres sont agglutinées par un pot calcaire, etc. Cette théorie rend raison de tous les phénomènes et de toutes les singularités que s'observent dans le mélange de produits du feu et de dépôts de l'eau, et un infinite de preuves de différents genres, mais que seroyant étrangers à ces mémoires. Concurrent à démontrer, l'existence d'un ancien plateau qui est livre de plusieurs centaines de toises au-dessus du sol actuel de vallées et du niveau de la mer, que couvroit non seulement le val di Noto, mais encore toute la Sicile. Et dont les débris ont forment toutes les montagnes actuellement existentes, à l'exception de l'Etna. It is not the explanation here given by the Chevalier de Dolomieu, of the manner in which this great mass of land was formed in the sea, that is concerned with the subject at present under our examination. But certain facts set forth in the memoir, and a certain conclusion which is there endeavored to be drawn from those interesting facts 74. This will be understood by considering, first, it is on all hands acknowledged, that the stratified matter of the globe was successively deposited in the bottom of the sea. Secondly, it is also agreed, that this great mass of Sicily, formed originally under the sea, was afterwards placed in the atmosphere, whether by the retreat of the sea or by the elevation of the land. And now, lastly, we are of one mind with respect to the present shape of things, as having been produced by the wasting away of great part of that mass which had been once continued all over the island, as high at least as the tops of the mountains. I.e., about a mile above the level of the sea, we only differ in the time and agents which have been employed in this operation. On the one hand, the memoir now before us represents this great effect as belonging to an unknown cause, so far as we are ignorant of that grand debacle or catastrophe which changed the situation of the sea. On the other hand, the theory now proposed explains this operation, of forming those conical mountains of Sicily, and hollowing out its valleys, by known causes, and by employing powers the most necessary, the most constant, and the most general, that act upon the surface of the earth. But, besides explaining this change of land and water by an unknown cause, our author has here employed, for the removing of this mass of solid rock, powers which appear to me no ways adequate to the end proposed. The running of water upon the soft mud left by a river, given here as an example, corresponds indeed in some respects with the form of valleys. For, water acts upon the same principle, whether it makes a channel through the subtle sediment of a river, or through the travelled materials of a valley. But it is not here that there is any difficulty in conceiving the rivers of Sicily to have shaped the mountains and the valleys. It is in removing the masses of solid rock, which covered the whole surface of this land in successive strata, that any doubt could occur in ascribing the actual appearances of things to the natural operations of the earth. But it is here particularly that the retreat of the sea, in whatever manner supposed to be done, is altogether incompetent for the purpose which is now considered. I flatter myself, that when the Chevalier de Dolomieu, who has employed his uncommon talents in examining and elucidating the effects of fire in the bowels of those burning mountains, shall consider and examine the effects of time upon the surface of the earth, he will be ready to adopt my opinion, that there is no occasion to have recourse to any unknown cause, in explaining appearances which are everywhere to be found, although not always attended with such remarkable circumstances as those with which his labors have enriched natural history. It may be proper to give a view of the operations of nature upon the Apennines. It is from an account of a journey into the province of Abruzzo, by Sir William Hamilton. Phil. Trans 1786. The road follows the windings of the Garigliano, which is here a beautiful clear trout stream, with a great variety of cascades and waterfalls, particularly a double one at Isola, near which place Cicero had a villa. And there are still some remains of it, though converted into a chapel. The valley is extensive, and rich with fruit trees, corn, vines, and olives. Large tracts of land are here and there covered with woods of oak and chestnut, all timber trees of the largest size. The mountains nearest the valley rise gently, and are adorned with either modern castles, towns, and villages, or the ruins of ancient ones. The next range of mountains, rising behind these, are covered with pines, larches, and such trees and shrubs as usually abound in a like situation. And above them a third range of mountains and rocks, being the most elevated part of the Apennine, rise much higher, and, being covered with eternal snow, make a beautiful contrast with the rich valley above mentioned. And the snow is at so great a distance as not to give that uncomfortable chill to the air which I have always found in the narrow valleys of the Alps and the Tyrol. Having thus examined the alpine countries both of the Old World and the New, it remains to observe some river in a more low or level country emptying itself into a sea that does not communicate with the ocean. The Wolga will now serve for this purpose, and we shall take our facts from the observations of those men of science who were employed by their enlightened sovereign to give the natural as well as the economical history of her dominions. Russia may be considered as a square plain, containing about 40 degrees of longitude, and 20 of latitude, that is, between the 47 degrees and 67 degrees. The east side is bounded by the Ural Mountains, running in a straight line from north to south. The west is bounded by Poland. The south reaches to the Caspian and Black Seas, as does the north to the Polar Ocean. The greatest part of the water which falls upon this extensive country is delivered into the Caspian by the river Wolga. And this water runs from the east and west sides, gathered in two great rivers, the Kama and the Oka. The water thus gathered from the two opposite extremities of this great kingdom meet in the middle with the Wolga, which receives its water from the north side. We thus find the water of this great plain running in all directions to its center. Had this been the lowest place, here would have been formed a sea or lake. But this water found a lower place in the bed of the Caspian, and into this basin it has made its way, in forming to itself a channel in the great plain of the Wolga. Our present purpose is to show that this channel, which the Wolga has cut for itself, had been once a continued mass of solid rock and horizontal strata, which in the course of time has been hollowed out to form a channel for those waters. These waters have been traversing all that plain, and have left protuberances as so many testimonies of what had before existed, for, we here find the horizontal strata cut down and worn away by the rivers. M. Pallas gives us very good reason to believe that the Caspian Sea had formerly occupied a much greater extent than at present. There are the marks of its ancient banks. And the shells peculiar to the Caspian Sea are found in the soil of that part of its ancient bottom which it has now deserted, and which forms the low saline steppe. He also makes it extremely probable that the Caspian then communicated with the Euxine or Black Sea. And that the breaking through of the channel from the Euxine into the Mediterranean had occasioned the disjunction of those seas which had been before united. As the surface of the Caspian is lowered by the great evaporation from that sea surrounded with dry deserts. However that may he, it is plain, that throughout all this great flat inland country of Russia, the solid rocks are decaying and wearing away by the operation of water, as certainly, though perhaps not so rapidly, as in the more mountainous regions of the earth. If there is so much of the solid parts worn and washed away upon the surface of this earth, as represented in our theory, and if the rivers have run so long in their present courses, it may perhaps be demanded, why are not all the lakes filled up with soil? And why have not the Black and Caspian seas become land or marshy ground, with rivers passing through them to the ocean? Here is a question that may be considered either as being general to all the lakes upon the earth, or as particular to every lake which should thus find a proper explanation in the theory. With regard to the last of these, the question has already been considered in this view, when the particular case of the Rhone was taken as an example. And now we are only to consider the question as general to the globe, or so far as belonging to the theory, without particularizing any one case. It must be evident, that the objection to the theory, here supposed to be made, is founded necessarily upon this, that the solid basis of our continent, on whose surface are found the lakes in question, is preserved without change, because otherwise, the smallest variation in the basis may produce the most sensible effects upon the surface. And in this manner might be produced dry land where there had been a lake, or a lake where none had been before. But, as the present theory is founded upon no such principle of stability in the basis of our land, no objection, to the wasting operations of the surface of the earth, can be formed against our theory, from the consideration of those lakes, when the immediate cause of them should not appear. The natural tendency of the operations of water upon the surface of this earth is to form a system of rivers everywhere, and to fill up occasional lakes. The system of rivers is executed by wearing and wasting away the surface of the earth. And this, it must be allowed, is perfect or complete, at least so far as consistent with another system, which would also appear to be in nature. This is a system of lakes with which the rivers are properly connected. Now, as there are more ways than one by which a lake may be formed, consistent with the theory, the particular explanation of every lake must be left to the natural history of the place, so far as this shall be found sufficient for the purpose. There are many places which give certain appearances, from which it is concluded, by most intelligent observators, that there had formerly existed great lakes of fresh water, which had been drained by the discharge of those waters through conduits formed by some natural operation. And those naturalists seem to be disposed to attribute to some great convulsion, rather than to the slow operation of a rivulet, those changes which may be observed upon the surface of the earth. Let us now examine some of those appearances, in order to connect them with that general system of moving water which we have been representing as everywhere modifying the surface of the earth on which we dwell. It is the P. Chrysologue de Gy, who gives the following description. Journal de Physique, Avril 1787. La principauté de Porrentruy l'emporte encore nce genre sur le reste du jura à ce chuil peroit. On pourra en juger sur les circonstances locales que j'y vais rapport. Un parti de cette principauté est divisé en quatre grandes vallées, d'environs 4 lieues de long, sur 3 quarts d'rou un de large. Séparés par autant de chaînes de montagnes fortes élèves et larges en quelques endroits d'une loïté de mai. Les extrémités de chacune de ces vallées sont plus élevées que le milieu, et on n'y peut pas en sortir par ces extrémités sans beaucoup monter. Mais ces vallées ont de communications entre elles par un pente assez douce à travers ces masses énormes de montagnes que les séparent, et que sont capables au niveau du milieu de vallées sur 300, 400, 500 toises de hauteur et dans toute leur largeur. On pourrait assez justement comparer ces vallées à de berceaux poses les uns à côté de autres, dont les extrémités, remplies en talus, seroyant plus élèves que les côtes, et dont ces côtés seroyant coupes jusqu'au fond. Pour laisser un passage de l'un à l'autre. J'ai connu sept à huit passages semblables à travers ces hautes montagnes, dans un quart d'environ 4 à 5 lieues, et dont 4 aboutissent à la vallée de Mouthier Grandval. Ces passages sont évasés dans l'Odessus, d'environ un demi-lieu par endroits, mais leurs parois, en talus, se rejoignent dans le fond au col un ruisseau. On a pratique de routes sur quelques uns de ces talus, mais les roches sont quelquefois si resserrées et si escarpées, qu'on a été obligé de construire un canal sur le ruisseau, pour y faire passer la route. C'est là que l'on voit à son aise, la nature de ces roches primitives, leur direction, leur inclinaison, et de tous leurs autres accidents que demanderaient chacun une dissertation particulière trop longue pour le moment. Il faut les avoir vus pour essayer faire une juste idée de sentiments de grandeur, de surprise, et d'admiration quels inspirant, et que l'on n'y peut pas exprimer par de paroles. Cependant, les sources de ruisseau, aussi l'on veut de rivières que traversent ces montagnes, sont beaucoup plus basses que les sommets de montagnes elles-mêmes, ces sources n'y font donc pas la cause de ces effets merveilleux. Il a fallu un agent plus puissant pour creuser ces abîmes. M. de la Metherie has taken a very enlightened view of the country of France, and has given us a plan of the different ridges of mountains that may be traced in that kingdom, Journal de Physique, Janvier 1787. Now there is a double purpose in natural history to which such a plan as this may be applied, viz. First, to trace the nature of the solid parts, on which the soil for vegetation rests, and, secondly, to trace the nature of the soil or cultivated surface of the earth, on which depends the growth of plants. With regard to the first, we may see here the granite raising up the strata, and bringing them to the light, where they appear on each side of those centrical ridges. What M. de la Metherie calls monts secondaries, I would call the proper strata of the globe, whether primary or secondary. And the monts granite, I would consider as mineral masses, which truly, or in a certain sense, are secondary, as having been made to invade, in a fluid state, the strata from below, when they were under water. And which masses had served to raise the country above the level of the ocean. But this is not the subject here immediately under consideration. We are now tracing the operations of rivers upon the surface of the earth, in order to see in the present state of things a former state, and to explain the apparent irregularity of the surface and confusion of the various mineral bodies. By finding order in the works of nature. Or a general system of the globe, in which the preservation of the habitable world is consulted. For this last purpose also the mineral map of M. de la Metherie is valuable. It gives us a plan of the valleys of the great rivers, and their various branches, which, however infinitely ramified, may be considered as forming each one great valley watered, or rather drained, by its proper river. But the view I would now wish to take of those valleys, is that of habitable and fertile countries formed by the attrition of those rivers. And to perceive the operation of water wearing down the softer and less solid parts, while the more hard and solid rocks of the ridges, as well as scattered mountains, had resisted and preserved a higher station. In this map, for example, let us suppose the first and second ridge of our author's plan to be joined at the mouth of the Loire, and retain the water of that river, as high as the summit of its surrounding ridges. This great valley of the Loire, which at present is so fine and fertile a country, would become a lake. In like manner as the proper valley of the Rhône, above Street Maurice, would be drowned by shutting up that gap of the mountains through which the Rhône passes in order to enter the plain of Geneva. This is the view that P. Chrysologue takes of those small valleys formed between the ridges of the Jura. But this is not perhaps the just view of the subject. For though by closing the gap by which the Loire or Rhône passes through the enclosing ridge, the present country above would certainly be overflowed by the accumulated waters, yet it is more natural to suppose that the great gap of the Loire or the Rhône had been formed gradually, in proportion as the enclosed country had been worn down and transported to the sea. We have but to consider, that the attrition of those transported materials must have been as necessary for the hollowing out of those gaps in the solid rock of the obstructing mountains, as the opening of those gaps may have been for the transporting of those materials to the sea. But it is perhaps impossible, from the present appearance of things, to see what revolutions may have happened to this country in the course of its degradation, what lakes may have been formed, what mountains of softer materials may have been leveled, and what basins of water filled up and obliterated. This general view of the valley of the Loire, and all its branches, is perhaps too extensive to be admitted in this reasoning from effect to cause. We must approximate it by an intermediate step, which will easily be acknowledged as entering within the rule. It is in Forez, near the head of the Loire. There we find the plain of Mont Brisson, 40,000 toises or 22 miles long and half as wide, surrounded by a ridge of granite mountains on every side. Here the river, which is a small branch of the Loire, enters at the upper end of the plain, as M. de Bournon has described, 75 par un gorge trace etroit et tortues and goes out in like manner at the under end. Those French philosophers, who have seen this plain, have little doubts of this having been a lake, that is to say, they easily admit of the original continuity of those ridges of mountains in which the gaps are now found, through which the river passes. But upon those principles it must be evident, that the river has hollowed out that plain, at the same time that it had formed the gaps in those ridges of the granite mountains. The only solid part, or original stratum, which M. de Bournon has described as having seen in this plain, is a decomposing grès or sandstone. But there is reason to suppose, that there had been both calcareous and argillaceous or marly strata filling the hollow of that space which is enclosed by the granite mountains. Consequently, no difficulty in conceiving that the river, which must wear away a passage through those mountains, should also hollow out the softer materials within, and thus form the plain, or rather a succession of plains, in proportion as the level of the water had been lowered with the wearing mountains. If we are allowed to make this step, which I think can hardly be refused, we may proceed to enlarge our view, by comprehending, first, the valleys of the Rhône, secondly, the countries of the Seine and Rhône, above the mountains through which those two rivers in conjunction have broke, below Lyons, and, lastly, that country of the Rhône and Durance which is almost enclosed by the surrounding mountains, meeting at the mouth of the Rhône. But this reasoning will equally apply to the countries of the Garonne, the Loire, and the Seine. One observation more may now be made with regard to the courses of great rivers, and the fertile countries which they form in depositing the travelled soil. It is this: that though those rivers have hollowed out their beds and raised their banks, though they are constantly operating in forming fertile soil in one place and destroying it in another, and though, in many particular situations, the fertile countries, formed at the mouths of those rivers, are visibly upon the increase, yet the general progress of those operations is so slow, that human history does not serve to give us information almost of any former state of things. The Nile will serve as an example of this fact. The river Nile, which rises in the heights of Ethiopia, runs an amazing tract through desert countries, and discharges its waters near the bottom of the Mediterranean Sea, fertilizes a long valley among barren countries with which it is surrounded, and thus lays the foundation of a kingdom, which, from its situation and the number of people it can maintain and easily bring together for any manner of action, is perhaps the strongest that can well be imagined. Accordingly, it has been of old a great kingdom, that is to say, a powerful state within itself, and has left monuments of this power, which have long been the admiration of the world. The most ancient Grecian histories mention these monuments as being no better known, with regard to their dates and authors, than they are at this day. The conclusion here meant to be drawn is this, that, in a period of time much more ancient than the most ancient periods in human history, Egypt had been a country formed and watered by the Nile in like manner as it is at present. That though continual changes are making in this as well as in every other river, yet, on the whole, no sensible alteration can be discerned within the compass of human experience. Consequently, it is only by considering, in a scientific manner, the nature of things, and making allowances for operations which have taken place in time past, that any competent judgment can be formed of the present shape and condition of countries, or of any particular place upon the surface of this earth, so far as regards its date, its causes, or its future state. Nothing, almost, but the kingdom of Egypt would have formed those stupendous monuments of art and labor, and nothing but the present state of Egypt, fertilized by the Nile, could have formed that powerful kingdom which might execute those works. Thus there is a system of mountains and valleys, of hills and plains, of rivulets and rivers, all of which are so perfectly connected, and so admirably proportioned, in their forms and quantities, like the arteries and veins of the animal body, that it would be absurd to suppose anything but wisdom could have designed this system of the earth, in delivering water to run from the higher ground, or that anything could have formed this beautiful disposition of things but the operation of the most steady causes. Operations which, in the unlimited succession of time, has brought to our view scenes which seem to us to have been always, or to have been in the original construction of this earth. To suppose the currents of the ocean to have formed that system of hill and dale, of branching rivers and rivulets, divided almost ad infinitum, which assemble together the water poured at large upon the surface of the earth. In order to nourish a great diversity of animals calculated for that moving element, and which carry back to the sea the superfluity of water, would be to suppose a systematic order in the currents of the ocean, an order which, with as much reason, we might look for, in the wind. The diversity of heights upon the surface of the earth, and of hardness and solidity in the masses of which the land is formed, is doubtless governed by causes proper to the mineral kingdom, and independent either of the atmosphere or sea. But the form and structure by which the surface of the earth is fitted peculiarly to the purpose of this living world, in giving a fertility which sustains both plants and animals, is only caused by those powers which work upon the surface of the earth, those powers, the operation of which men in general see with indifference every day, sometimes with horror or apprehension. The system of sustaining plants and animals upon a surface where fertility abounds, and where even the desert has its proper use, is to be perceived from the summit of the mountain to the shore within the region of the sea. And although we have principally taken the Alps, or alpine situations, for particular examples, in illustrating this operation of the waters upon the surface of the earth, it is because the effects are here more obvious to every inquirer, and not because there is here to be acknowledged any other principle than that which is to be found on all the surface of the earth, a principle of generation in one sense, and of destruction in another. We may also find in this particular, a certain degree of confirmation to another part of the same theory, a part which does not come so immediately within our view, and concerning which so many contradictory hypotheses have been formed. Naturalists have supposed a certain original construction of mountains, which constitution of things, however, they never have explained. They have also distinguished those which have evidently been formed in another manner, that is to say, those the materials of which have been collected in the ocean. Now, here are two things perfectly different. On the one hand, original mountains formed by nature, but we know not how, endued with solidity, but not differing in this respect from those of a posterior formation. On the other hand, secondary mountains, formed by the collection of materials in the sea, therefore, not having solidity as a quality inherent in their constitution, but only occasional or accidental in their nature. If, therefore, it be the natural constitution of things upon the surface of this earth to indurate and become solid, however originally formed loose and incoherent, we should thus find an explanation of the consolidation of those masses which had been lately formed of the loose materials of the ocean. If, on the contrary, we find those pretended primitive mountains, those bodies which are endued with hardness and solidity, wasting by the hand of time, and thus wearing in the operations natural to the surface of the earth, where shall we find the consolidating operations, those by which beds of shells have been transformed into perfect marble, and siliceous bodies into solid flint? Or how reconcile those opposite intentions in the same cause? Nothing can be more absurd than to suppose a collection of shells and corals, amassed about the primitive mountains of the earth, to become mountains equally solid with the others, upon the removal of the sea. It would be inconsistent with every principle of sound reasoning to suppose those masses of loose materials to oppose equal resistance to the wasting and destroying operations of the surface of the earth, as do those pretended primitive masses, which might be supposed endued with natural hardness and solidity. Yet, consult the matter of fact, and it does not appear that there is any difference to be perceived. There are lofty mountains to be found both of the one kind and the other. Both those different masses yield to the wasting operations of the surface, and they are both carried away with the descending waters of the earth. It is not here meant to affirm, that a mass of marble, which is a calcareous substance, opposes equal resistance, whether to the operations of dissolution or attrition, as a mass composed of granite or of quartz. It is only here maintained that there are in the Alps lofty mountains of marble, as there are in other places lower masses of granite and its accompanying schistous. But that which is particularly to be attended to here is this: in all countries of the earth, whether of primitive masses or those of secondary formation, whether uniform and homogeneous, or compound and mixed of those two different kinds of bodies, the system is always the same, of hills and valleys, lakes and rivers, ravines and streams. No man can say, by looking into the most perfect map, what is primary or what secondary in the constitution of the globe. It is the same system of larger rivers branching into lesser and lesser in a continued series, of smaller rivers in like manner branching into rivulets, and of rivulets terminating at last into springs or temporary streams. The principle is universal, and, having learned the natural history of one river, we know the constitution of every other upon the face of the earth. Thus all the surface of this earth is formed according to a regular system of heights and hollows, hills and valleys, rivulets and rivers, and these rivers return the waters of the atmosphere into the general mass, in like manner as the blood, returning to the heart, is conducted in the veins. But as the solid land, formed at the bottom of the sea or in the bowels of the earth, could not be there constructed according to that system of things which we find so widely pursued upon the surface of the globe, it must be by wasting the solid parts of the land that this system of the surface has been formed, in like manner as it is by the operations of the sea that the shape of the land is determined, upon the shore. Thus it has been shown, that the general tendency of the operations natural to the surface of the globe is to wear the surface of the earth, and waste the land. Consequently that, however long the continents of this earth may be supposed to last, they are on the whole in a constant state of diminution and decay, and, in the progress of time, will naturally disappear. Hence conformation is added to that mineral system of the earth, by which the present land is supposed to have acquired solidity and hardness, and according to which future land is supposed to be preparing from the materials of the sea and former continents, which land will be brought to light in time, to supply the place of that which necessarily wastes, in serving plants and animals. But what is here more particularly to the purpose is this: that we find an explanation of that various shape and conformation which is to be observed upon the surface of this earth, as being the effect of causes which are constant and unremitting in their operation, which are widely adapted to the end or absolutely necessary in the system of this world, and which, in the indefinite course of time, become unlimited in their effect, or powerful in any conceivable degree. It is not sufficient for establishing the present theory, to refute that most unscientific hypothesis, adopted by some eminent philosophers, of mountains and valleys being the effect of currents in the ocean. It is necessary to see what is their proper cause, and to show that by no other cause known could the general effect, which is of such importance in the system of this world, be actually produced. It is for this reason that we have endeavored to show that there is a general, and universal system of river and valley, which renders the surface of this earth a sort of organized body destined to a purpose which it perfectly fulfills. But to see the full force of this argument, taken from that order of things which is perceived in that system of valley and river all over the earth, let us examine, first, what would be the effect, in the constitution of this world, of bodies of land formed upon no such system. And, secondly, what would be the effect of the natural constitution of this world and meteorological operations of the atmosphere, if continued for a sufficient length of time, upon a mass of land without any systematic form. For this purpose we shall take for example a portion of this earth, which is the best known to us, that is the southwestern part of Europe, in order to compare its present state, which so perfectly fulfills the purpose of this world, with that in which no order of valley and of rivers should be found. Let us begin at the summit, which is the Mont Blanc. At present the water, falling from the heavens upon this continent, is gathered into a system of rivers which run through valleys, and is delivered at last into the Adriatic, the Mediterranean, the Atlantic, and the German seas. All the rest of this continent, except some lakes and marshes, is dry land, properly calculated, for the sustenance of a variety of plants and animals, and so fulfills the purpose of a habitable earth. Now, destroy that system of river and valley, and the whole would become a mixture of lakes and marshes, except the summits of a few barren rocks and mountains. No regular channels for conveying the superabundant water being made, everything must be deluged, and nothing but a system of aquatic plants and animals appear. A continent of this sort is not found upon the globe. And such a constitution of things, in general, would not answer the purpose of the habitable world which we possess. It is therefore necessary to modify the surface of such a continent of land, as had been formed in the sea, and produced, by whatever means, into the atmosphere for the purpose of maintaining that variety of plants and animals which we behold. And now we are to examine how far the proper means for that modification is to be found necessarily in the constitution of this world. If we consider our continent as composed of such materials as may decay by the influence of the atmosphere, and be moved by water descending from the higher to the lower ground, as is actually the case with the land of our globe, then the water would gradually form channels in which it would run from place to place. And those channels, continually uniting as they proceed to the sea or shore, would form a system of rivers and their branchings. But this system of moving water must gradually produce valleys, by carrying away stones and earthy matter in their floods. And those valleys would be changing according to the softness, and hardness, destructibility or indestructibility of the solid parts below. Still however the system of valley and river would be preserved. And to this would be added the system of mountains, and valleys, of hills and plains, to the formation of which the unequal wearing down of the solids must in a great measure contribute. Here therefore it is evident, first, that the great system upon the surface of this earth, is that of valleys and rivers, secondly, that no such system could arise from the operations of the sea when covering the nascent land. Thirdly, that this system is accomplished by the same means which are employed for procuring soil from the decaying rocks and strata. And, lastly, that however this system shall be interrupted and occasionally destroyed, it would necessarily be again formed in time, while the earth continued above the level of the sea. Whatever changes take place from the operation of internal causes, the habitable earth, in general, is always preserved with the vigor of youth, and the perfection of the most mature age. We cannot see man cultivate the field, without perceiving that system of dry land provided by nature in forming valleys and rivers. We cannot study the rocks and solid strata of the earth, those bulwarks of the field and shore, without acknowledging the provident design of nature in giving as much permanency to our continent, as is consistent with sufficient fertility. And we cannot contemplate the necessary waste of a present continent, without perceiving the means for laying the foundation of another. But the evidence of those truths is not open to a vulgar view, media are required, or much reasoning. And between the first link and the last, in this chain, what a distance, from the wasting of hard bodies upon the surface of the earth, to the formation of a solid rock at the bottom of the sea. Chapter 14. Summary of the doctrine which has been now illustrated. The system of this earth appears to comprehend many different operations, and it exhibits various powers cooperating for the production of those effects which we perceive. Of this we are informed by studying natural appearances, and in this manner we are led to understand the nature of things, in knowing causes. That our land, which is now above the level of the sea, had been formerly under water, is a fact for which there is everywhere the testimony of a multitude of observations. This indeed is a fact which is admitted upon all hands. It is a fact upon which the speculations of philosophers have been already much employed, but it is a fact still more important, in my opinion, than it has been ever yet considered. It is not, however, as a solitary fact that any rational system may be founded upon this truth, that the earth had been formerly at the bottom of the sea. We must also see the nature and constitution of this earth as necessarily subsisting in continual change, and we must see the means employed by nature for constructing a continent of solid land in the fluid bosom of the deep. It is then that we may judge of that design, by finding ends and means contrived in wisdom, that is to say, properly adapted to each other. We have now given a theory founded upon the actual state of this earth, and the appearances of things, so far as they are changing. And we have, in support of that theory, adduced the observations of scientific men, who have carefully examined nature and described things in a manner that is clear and intelligible. We are now to take a review of the principal points on which this theory hangs, and to endeavor to point out the importance of the subject, and the proper manner of judging with regard to a theory of the earth, how far it is conformed to the general system of nature, which has for object a world. If it should be admitted, that this earth had been formed by the collection of materials deposited within the sea, there will then appear to be certain things which ought to be explained by a theory, before that theory be received as belonging to this earth. These are as follows. First, we ought to show how it came about that this whole earth, or by far the greatest part in all the quarters of the globe, had been formed of transported materials collected together in the sea. It must be here remembered, that the highest of our mountainous countries are equally formed of those travelled materials as are the lowest of our plains. We are not therefore to have recourse to anything that we see at present for the origin of those materials which actually compose the earth. And we must show from whence had come those travelled materials, manufactured by water, which were employed in composing the highest places of our land. Secondly, we must explain how those loose and incoherent materials had been consolidated, as we find they are at present. We are not here to allow ourselves the liberty, which naturalists have assumed without the least foundation, of explaining everything of this sort by infiltration, a term in this case expressing nothing but our ignorance. Thirdly, the strata are not always equally consolidated. We often find contiguous strata in very different states with respect to solidity, and sometimes the most solid masses are found involved in the most porous substance. Some explanation surely would be expected for this appearance, which is of a nature so conclusive as ought to attract the attention of a theorist. Fourthly, it is not sufficient to show how the earth in general had been consolidated. We must also explain how it comes to pass that the consolidated bodies are always broken and intersected by veins and fissures. In this case, the reason commonly given, that the earth exposed to the atmosphere had shrunk like moist clay, or contracted by the operation of drying, can only show that such naturalists have thought but little upon the subject. The effect in no shape or degree corresponds to that cause, and veins and fissures, in the solid bodies, are no less frequent under the level of the sea, than on the summits of our mountains. Fifthly, having found a cause for the fracture and separation of the solid masses, we must also tell from whence the matter with which those chasms are filled, matter which is foreign both to the earth and sea, had been introduced into the veins that intersect the strata. If we fail in this particular, what credit could be given to such hypotheses as are contrived for the explanation of more ambiguous appearances, even when those suppositions should appear most probable? Sixthly, supposing that hitherto everything had been explained in the most satisfactory manner, the most important appearances of our earth still remain to be considered. We find those strata that were originally formed continuous in their substance, and horizontal in their position, now broken, bended, and inclined, in every manner and degree. We must give some reason in our theory for such a general changed state and disposition of things, and we must tell by what power this event, whether accidental or intended, had been brought about. Lastly, whatever powers had been employed in preparing land, while situated under water, or at the bottom of the sea, the most powerful operation yet remains to be explained. This is the means by which the lowest surface of the solid globe was made to be the highest upon the earth. Unless we can show a power of sufficient force, and placed in a proper situation for that purpose, our theory would go for nothing, among people who investigate the nature of things, and who, founding on experience, reason by induction from effect to cause. Nothing can be admitted as a theory of the earth which does not, in a satisfactory manner, give the efficient causes for all these effects already enumerated. For, as things are universally to be acknowledged in the earth, it is essential in a theory to explain those natural appearances. But this is not all. We live in a world where order everywhere prevails, and where final causes are as well known, at least, as those which are efficient. The muscles, for example, by which I move my fingers when I write, are no more the efficient cause of that motion, than this motion is the final cause for which the muscles had been made. Thus, the circulation of the blood is the efficient cause of life. But, life is the final cause, not only for the circulation of the blood, but for the revolution of the globe, without a central luminary, and a revolution of the planetary body. There could not have been a living creature upon the face of this earth. And, while we see a living system on this earth, we must acknowledge, that in the solar system we see a final cause. Now, in a theory which considers this earth as placed in a system of things where ends are at least attained, if not contrived in wisdom, final causes must appear to be an object of consideration, as well as those which are efficient. A living world is evidently an object in the design of things, by whatever being those things have been designed, and however either wisdom or folly may appear in that design. Therefore the explanation, which is given of the different phenomena of the earth, must be consistent with the actual constitution of this earth as a living world, that is, a world maintaining a system of living animals and plants. Not only are no powers to be employed that are not natural to the globe, no action to be admitted of except those of which we know the principle, and no extraordinary events to be alleged in order to explain a common appearance. The powers of nature are not to be employed in order to destroy the very object of those powers. We are not to make nature act in violation to that order which we actually observe, and in subversion of that end which is to be perceived in the system of created things. In whatever manner, therefore, we are to employ the great agents, fire and water, for producing those things which appear. It ought to be in such a way as is consistent with the propagation of plants and life of animals upon the surface of the earth. Chaos and confusion are not to be introduced into the order of nature, because certain things appear to our partial views as being in some disorder. Nor are we to proceed in feigning causes, when those seem insufficient which occur in our experience. Animal life being thus considered as an object in the view of nature, we are to consider this earth as being the means appointed for that end. And then the question is suggested, how far wisdom may appear in the constitution of this earth, as being means properly adapted to the system of animal life, which is evidently the end. This is taking for granted, that there is a known system of the earth which is to be tried, how far properly adapted to the end intended in nature. But it is this very system of the earth which is here the subject of investigation. And it is in order to discover the true system that we are to examine, by means of final causes, every theory which pretends to show the nature of that system, or to assign efficient causes to physical events. Here then we have a rule to try the propriety of every operation which should be acknowledged as in the system of nature, or as belonging to the theory of this earth. It is not necessary that we should see the propriety of every natural operation. Our natural ignorance precludes us from any title to form a judgment in things of which we are not properly informed. But, no suppositions of events or explanations of natural appearances are to be admitted into our theory, if the propriety of those alleged operations is not made to appear. We are now to make an application. This earth, which is now dry land, was under water, and was formed in the sea. Here is a matter of fact, and not of theory, so far as it can be made as evident as any thing of which we have not seen the immediate act or execution. But the propriety of this matter of fact is only to be perceived in making the following acknowledgment, that the origin of this earth is necessarily placed in the bottom of the sea. In supposing any other origin to this habitable earth, we would see the impropriety of having it covered with water, or drowned in the sea. But, being formed originally at the bottom of the sea, if we can explain the phenomena of this earth by natural causes, we will acknowledge the wisdom of those means, by which the earth, thus formed at the bottom of the sea, had been perfected in its nature, and made to fulfill the purpose of its intention, by being placed in the atmosphere. If the habitable earth does not take its origin in the waters of the sea, the washing away of the matter of this earth into the sea would put a period to the existence of that system which forms the admirable constitution of this living world. But, if the origin of this earth is founded in the sea, the matter which is washed from our land is only proceeding in the order of the system. And thus no change would be made in the general system of this world, although this particular earth, which we possess at present, should in the course of nature disappear. It has already been our business to show that the land is actually wasted universally, and carried away into the sea. Now, what is the final cause of this event? Is it in order to destroy the system of this living world, that the operations of nature are thus disposed upon the surface of this earth? Or, is it to perpetuate the progress of that system, which, in other respects, appears to be contrived with so much wisdom? Here are questions which a theory of the earth must solve. And here indeed, must be found the most material part by far of any theory of the earth. For, as we are more immediately concerned with the operations of the surface, it is the revolutions of that surface which forms, for us, the most interesting subject of inquiry. Thus we are led to inquire into the final cause of things, while we investigate an operation of such magnitude and importance, as is that of forming land of sea, and sea of land, of apparently reversing nature, and of destroying that which is so admirably adapted to its purpose. Was it the work of accident, or effect of an occasional transaction, that by which the sea had covered our land? Or, was it the intention of that mind which formed the matter of this globe, which endued that matter with its active and its passive powers, and which placed it with so much wisdom among a numberless collection of bodies, all moving in a system? If we admit the first, the consequence of such a supposition would be to attribute to chance the constitution of this world, in which the systems of life and sense, of reason and intellect, are necessarily maintained. If again we shall admit, that there is intention in the cause by which the present earth had been removed from the bottom of the sea, we may then inquire into the nature of that system in which a habitable earth, possessed of beauty, arranged in order, and preserved with economy, had been formed by the mixture and combination of the different elements, and made to rise out of the wreck of a former world. In examining the structure of our earth, we find it no less evidently formed of loose and incoherent materials, than that those materials had been collected from different parts, and gathered together at the bottom of the sea. Consequently, if this continent of land, first collected in the sea, and then raised above its surface, is to remain a habitable earth, and to resist the moving waters of the globe, certain degrees of solidity or consolidation must be given to that collection of loose materials, and certain degrees of hardness must be given to bodies which were soft or incoherent, and consequently so extremely perishable in the situation where they now are placed. But, at the same time that this earth must have solidity and hardness to resist the sudden changes which its moving fluids would occasion, it must be made subject to decay and waste upon the surface exposed to the atmosphere. For, such an earth as were made incapable of change, or not subject to decay, could not afford that fertile soil which is required in the system of this world, a soil on which depends the growth of plants and life of animals. The end of its intention. Now, we find this earth endued precisely with that degree of hardness and consolidation, as qualifies it at the same time to be a fruitful earth, and to maintain its station with all the permanency compatible with the nature of things, which are not formed to remain unchangeable. Thus we have a view of the most perfect wisdom, in the contrivance of that constitution by which the earth is made to answer, in the best manner possible, the purpose of its intention, that is, to maintain and perpetuate a system of vegetation, or the various race of useful plants, and a system of living animals, which are in their turn subservient to a system still infinitely more important, I mean, a system of intellect. Without fertility in the earth, many races of plants and animals would soon perish, or be extinct. And, without permanency in our land, it were impossible for the various tribes of plants and animals to be dispersed over all the surface of a changing earth. The fact is, that fertility, adequate to the various ends in view, is found in all the quarters of the world, or in every country of the earth. And, the permanency of our land is such, as to make it appear unalterable to mankind in general, and even to impose upon men of science, who have endeavored to persuade us that this earth is not to change. Nothing but supreme power and wisdom could have reconciled those two opposite ends of intention, so as both to be equally pursued in the system of nature, and both so equally attained as to be imperceptible to common observation, and at the same time a proper object for the human understanding. We thus are led to inquire into the efficient causes of this constitution of things, by which solidity and stability had been bestowed upon a mass of loose materials, and by which this solid earth, formed first at the bottom of the sea, had been placed in the atmosphere, where plants and animals find the necessary conditions of their life. Now, we have shown, that subterraneous fire and heat had been employed in the consolidation of our earth, and in the erection of that consolidated body into the place of land. The prejudices of mankind, who cannot see the steps by which we come at this conclusion, are against the doctrine, but prejudice must give way to evidence. No other theory will in any degree explain appearances, while almost every appearance is easily explained by this theory. We do not dispute the chemical action and efficacy of water, or any other substance which is found among the materials collected at the bottom of the sea. We only mean to affirm, that every action of this kind is incapable of producing perfect solidity in the body of earth in that situation of things, whatever time should be allowed for that operation. And that whatever may have been the operations of water, aided by fire, and evaporated by heat, the various appearances of mineralization, everywhere presented to us in the solid earth, and the most perfect objects of examination, are plainly inexplicable upon the principle of aqueous solution. On the other hand, the operation of heat, melting incoherent bodies, and introducing softness into rigid substances which are to be united, is not only a cause which is proper to explain the effects in question, but also appears, from a multitude of different circumstances, to have been actually exerted among the consolidated bodies of our earth, and in the mineral veins with which the solid bodies of the earth abound. The doctrine, therefore, of our theory is briefly this, that, whatever may have been the operation of dissolving water, and the chemical action of it upon the materials accumulated at the bottom of the sea, the general solidity of that mass of earth, and the placing of it in the atmosphere above the surface of the sea, has been the immediate operation of fire or heat melting in expanding bodies. Here is a proposition which may be tried, in applying it to all the phenomena of the mineral region. So far as I have seen, it is perfectly verified in that application. We have another proposition in our theory, one which is still more interesting to consider. It is this, that as, in the mineral regions, the loose or incoherent materials of our land have been consolidated by the action of heat, so, upon the surface of this earth exposed to the fluid elements of air and water, there is a necessary principle of dissolution and decay, for that consolidated earth which from the mineral region is exposed to the day. The solid body being thus gradually impaired, there are moving powers continually employed, by which the summits of our land are constantly degraded, and the materials of this decaying surface travel towards the coast. There are other powers which act upon the shore, by which the coast is necessarily impaired, and our land subjected to the perpetual encroachment of the ocean. Here is a part of the theory with which every appearance of the surface may be compared. I am confident that it will stand the test of the most rigid examination, and that nothing but the most inconsiderate judgment may mistake a few appearances, which, when properly understood, instead of forming any subject of objection to the theory, will be found to afford it every reasonable support or confirmation. We have now seen, that in every quarter of the globe, and in every climate of the earth, there is formed, by means of the decay of solid rocks, and by the transportation of those movable materials, that beautiful system of mountains and valleys, of hills and plains, covered with growing plants, and inhabited by animals. We have seen, that, with this system of animal and vegetable economy, which depends on soil and climate, there is also a system of moving water, poured upon the surface of the earth 76. In the most beneficial manner possible for the use of vegetation, and the preservation of our soil. And that this water is gathered together again by running to the lowest place, in order to avoid accumulation of water upon the surface, which would be noxious. It is in this manner that we first have streams or torrents, which only run in times of rain. But the rainwater absorbed into the earth is made to issue out in springs, which run perpetually, and which, gathering together as they run, form rivulets, watering valleys, and delighting the various inhabitants of this earth. The rivulets again are united in their turn, and form those rivers which overflow our plains, and which alternately bring permanent fertility and casual devastation to our land. Those rivers, augmenting in their volume as they unite, pour at last their mighty waters into the ocean, and thus is completed that circulation of wholesome fluids, which the earth requires in order to be a habitable world. Our theory farther shows, that in the ocean there is a system of animals which have contributed so materially to the formation of our land. These animals are necessarily maintained by the vegetable provision, which is returned in the rivers to the sea, and which the land alone or principally produces. Thus we may perceive the mutual dependence upon each other of those two habitable worlds, the fluid ocean and the fertile earth. The land is formed in the sea, and in great part by inhabitants of that fluid world. But those animals, which form with their exuvii such a portion of the land, are maintained, like those upon the surface of the earth, by the produce of that land to which they formerly had contributed. Thus the vegetable matter, which is produced upon the surface of the earth in such abundance for the use of animals, and which, in such various shapes, is carried by the rivers into the sea. There sustains that living system which is daily employed to make materials for a future land. Here is a compound system of things, forming together one whole living world, a world maintaining an almost endless diversity of plants and animals, by the disposition of its various parts, and by the circulation of its different kinds of matter. Now, we are to examine into the necessary consequence of this disposition of things, where the matter of this active world is perpetually moved. In that salutary circulation by which provision is so wisely made for the growth and prosperity of plants, and for the life and comfort of its various animals. If, in examining this subject, we shall find that there is nothing in the system but what is necessary, that is, nothing in the means employed but what the importance of the end requires. If we shall find that the end is steadily pursued, and that there is no deficiency in the means which are employed. And if it shall be acknowledged that the end which is attained is not idle or insignificant, we then may draw this conclusion, that such a system is in perfect wisdom. And therefore that this system, so far as it is found corresponding properly with natural appearances, is the system of nature, and not the creature of imagination. Let us then take a cursory view of this system of things, upon which we have proceeded in our theory, and upon which the constitution of this world seems to depend. Our solid earth is everywhere wasted, where exposed to the day. The summits of the mountains are necessarily degraded. The solid and weighty materials of those mountains are everywhere urged through the valleys, by the force of running water. The soil, which is produced in the destruction of the solid earth, is gradually traveled by the moving water, but is constantly supplying vegetation with its necessary aid. This traveled soil is at last deposited upon the coast, where it forms most fertile countries. But the billows of the ocean agitate the loose materials upon the shore, and wear away the coast, with the endless repetitions of this active power, or this imparted force. Thus the continent of our earth, sapped in its foundation, is carried away into the deep, and sunk again at the bottom of the sea, from whence it had originated. We are thus led to see a circulation in the matter of this globe, and a system of beautiful economy in the works of nature. This earth, like the body of an animal, is wasted at the same time that it is repaired. It has a state of growth and augmentation, it has another state, which is that of diminution and decay. This world is thus destroyed in one part, but it is renewed in another. And the operations by which this world is thus constantly renewed, are as evident to the scientific eye, as are those in which it is necessarily destroyed. The marks of the internal fire, by which the rocks, beneath the sea are hardened, and by which the land is produced above the surface of the sea, have nothing in them which is doubtful or ambiguous. The destroying operations again, though placed within the reach of our examination, and evident almost to every observer, are no more acknowledged by mankind, than is that system of renovation which philosophy alone discovers. It is only in science that any question concerning the origin and end of things is formed, and it is in science only that the resolution of those questions is to be attained. The natural operations of this globe, by which the size and shape of our land are changed, are so slow as to be altogether imperceptible to men who are employed in pursuing the various occupations of life and literature. We must not ask the industrious inhabitant, for the end or origin of this earth. He sees the present, and he looks no farther into the works of time than his experience can supply his reason. We must not ask the statesman, who looks into the history of time past, for the rise and fall of empires. He proceeds upon the idea of a stationary earth, and most justly has respect to nothing but the influence of moral causes. It is in the philosophy of nature that the natural history of this earth is to be studied, and we must not allow ourselves ever to reason without proper data, or to fabricate a system of apparent wisdom in the folly of a hypothetical delusion. When, to a scientific view of the subject, we join the proof which has been given, that in all the quarters of the globe, in every place upon the surface of the earth, there are the most undoubted marks of the continued progress of those operations which wear away and waste the land, both in its height and width, its elevation and extension, and that for a space of duration in which our measures of time are lost. We must sit down contented with this limitation of our retrospect, as well as prospect, and acknowledge, that it is in vain to seek for any computation of the time, during which the materials of this earth had been prepared in a preceding world, and collected at the bottom of a former sea. The system of this earth will thus appear to comprehend many different operations, or it exhibits various powers cooperating for the production of those appearances which we properly understand in knowing causes. Thus, in order to understand the natural conformation of this country, or the particular shape of any other place upon the globe, it is not enough to see the effects of those powers which gradually waste and wear away the surface. We must also see how those powers affecting the surface operate, or by what principle they act. Besides, seeing those powers which are employed in thus changing the surface of the earth, we must also observe how their force is naturally augmented with the declivity of the ground on which they operate. Neither is it sufficient to understand by what powers the surface is impaired, for, it may be asked, why, in equal circumstances, one part is more impaired than another. This then leads to the examination of the mineral system, in which are determined the hardness and solidity, consequently, the permanency of those bodies of which our land is composed, and here are sources of indefinite variety. In the system of the globe everything must be consistent. The changing and destroying operations of the surface exposed to the sun and influences of the atmosphere, must correspond to those by which land is composed at the bottom of the sea. And the consolidating operations of the mineral region must correspond to those appearances which in the rocks, the veins, and solid stones, give such evident, such universal testimony of the power of fire, in bringing bodies into fusion, or introducing fluidity, the necessary prelude to solidity and concretion. Those various powers of nature have thus been employed in the theory, to explain things which commonly appear, or rather, it is from things which universally appear that causes have been concluded, upon scientific principles, for those effects. A system is thus formed, in generalizing all those different effects, or in ascribing all those particular operations to a general end. This end, the subject of our understanding, is then to be considered as an object of design. And, in this design, we may perceive either wisdom, so far as the ends and means are properly adapted, or benevolence, so far as that system is contrived for the benefit of beings who are capable of suffering pain and pleasure, and of judging good and evil. But, in this physical dissertation, we are limited to consider the manner in which things present have been made to come to pass, and not to inquire concerning the moral end for which those things may have been calculated. Therefore, in pursuing this object, I am next to examine facts, with regard to the mineralogical part of the theory, from which, perhaps, light may be thrown upon the subject, and to endeavor to answer objections, or solve difficulties, which may naturally occur from the consideration of particular appearances.